Hi, it's John Holloman at CNN Center, about to take you to the Jet Propulsion Laboratory in California, where there's about to be another news briefing on the Pathfinder mission to planet Mars. The information we have been given so far is that for about the past hour and a half, computers at the Jet Propulsion Lab have been receiving data from Pathfinder. They have used that data to paint a picture of just where it is, or at least how it is oriented on the surface of the planet. They are hoping to get a weather report from Mars very soon. This is the orientation of Pathfinder on the surface of Mars. If you look very closely, you can see some blue and red lines which represent the surface of Mars. This is how it looks right now, which is precisely the way it is supposed to look. It is only 2 degrees off of the perfectly horizontal orientation for the solar panels that are just beginning to receive some sunlight from the very early morning sun coming up on the landing site on Mars, as those solar panels charge the batteries on board the Sojourner rover, as well as the mothership Pathfinder. There are going to be some spectacular pictures which may well be sent back to Earth. Joining me from the Jet Propulsion Lab to talk us into this news conference, CNN's John Zarella, a man who's been to more space launches than anybody else at this joint. How does this compare to watching the space shuttle go up?
Well, you know, John, the space shuttle is always an exciting event when it lifts off. There's no question about that. I've seen probably 60 or 70 of those, and every one is spectacular. But there is certainly an unbelievable degree of drama going on here. It's funny, you know, we can't see any of what's going on yet, but the drama is there, and I think that's what makes this story so amazing. You know, some of our viewers have wanted to know out there, well, exactly where is Mars in the sky if they go out and take a look, and Donna Shirley, where can we see Mars? Can we see Mars right now?
Well, we asked our project scientist, and he didn't know. But then we asked the guy who programmed the computer, who did all the software, and he said it's low in the western sky.
So very low on the horizon, so it'd be pretty difficult for folks to see this time of the year.
Right. Maybe they can see it right after dark.
Some new information that we can get out very quickly before the briefing starts about what happened that you know now during the descent and landing.
Right. As far as we know, there were 3 bounces. And it took just 3 bounces, which is a very small number of bounces. And the first bounce was 18 Gs. That's 18 times the force of gravity. The second bounce, I think, was 9 Gs, which is nothing. And then it rolled for about 92 seconds and then stopped. And when it opened up, it was absolutely flat, 2.5 degrees tilt, which is absolutely nothing. So that was really incredible news. Now, we have qualified these systems to land at 55 Gs. So
means it was a very soft landing, right?
Very soft, gentle landing, which must mean that the radar altimeter worked perfectly and the airbags were cut loose just very low above the ground, and so it's just absolutely couldn't be better.
So all that animation that we have has to be redone now, right? Because it has it bouncing around too much on the surface before it comes to rest.
Right, we'll redo that.
Now you're going to get some of the information in that. Now we also heard just recently that that first packet of low-gain downlinked data about the health of the spacecraft is in.
Yes, it is. And as far as we know, it's completely in, and the engineers have been analyzing the data, and I think that's going to be the subject of this next press conference. And so, as far as we know, all of the systems are healthy, including the rover systems. So all the spacecraft seems to be working just great, and we're ready for the next step, which is to get the high-gain antenna pointed at the Earth.
We're going to go now to the presser. It's starting.
Also, start today a determination to be the masters of the science of our solar system. It is wonderful. I just want to spend a few moments saying how proud I am of these young people who are sitting on my left and those who think young that are over in the mission control and worked on this program across the agency. And I also would like to take this moment to thank the American taxpayers who have had confidence in NASA as we've gone through all these changes, and they stuck with us because it is their program, it is not our program, and we at NASA celebrate you for believing in us. Being a different kind of program, I was here in the spring, and a young man, Kirk Goodall, came up to me and said, Dan, we can't be on the internet because we're going to get too many hits. He said, I'm concerned because we only have a capacity for 5 to 10 million hits here at JPL. So I authorized him so that every person in America who wanted to turn on to the internet to watch this mission could do it. And he informed me we now have a capacity somewheres between 75 and 100 million people to tune into the internet, and they told me that by about 5 or 6 o'clock today they anticipated 40 million hits. This is exciting. We are now really in the electronic age, and I'm so proud that we could get this information to everyone who wants to see it. So let me at this point turn the program over to the real people who did it and tell you and all the people who work for you how proud I am, the Vice President, the President, and the American people, the people who allowed us to sit up here. Thank you very much.
Okay, well, I don't think I need to tell you how amazingly happy the flight team is, not just us, but our friends and family who are here. This is really a spectacular day. It's gone better than we really possibly could imagine. Sometimes we're pinching ourselves saying, is this really real? Or are we doing a simulation? But no, the lander is on the surface of Mars, and we're getting data back from it. It looks very, very good. The rover is also giving us data. I'll give you some more specifics in a minute. But I think this is definitely, I'm sure I'm speaking for everybody on the flight team, Tony Spear, Brian Muirhead, that this is definitely an experience that all of us will remember for the rest of our lives, that this is really special, and that we're on the surface of another planet, that we'll get to explore it over the next few weeks and months, and we will learn a great deal about both ourselves and our solar system. So we're really pleased. Let me just give you some basic statistics about the status of the lander and the rover, just so that I think most of it's gone on over the net, so you've probably heard it, but I'll summarize it. Jennifer Harris and the flight team are doing an excellent job of assessing the health and status. Basically, we do know now that the airbags are fully retracted and the pedals are deployed. Rob will talk more about the entry, descent, and landing process, what happened during that phase. But in the end, the lander appears to be tilted about 2.5 to 3 degrees, which is quite flat. In fact, we were having a little pool there at the last minute as far as what we were betting, and it was a little bit lower than what we were guessing. We routinely in our simulations get angles up at 10 or 15 degrees, so this is great that we're basically flat on the surface. The battery state of charge, which is a very important parameter for how well we're able to continue doing surface operations, right now is at 76%. Again, that's beyond what we thought it would be. We didn't use as much power or energy during entry, descent, and landing, which leaves more for surface operations. So there again, we're very pleased. The solar arrays are producing power on the lander. Obviously, that's a requirement for the mission to proceed, and they look like they're operating fine. So there again, we're pleased with that. The camera, for those of you who might have missed it, we did unlock the camera in this last set of activities. The camera is unlocked, it is functioning, and we're up actually, as we speak, probably doing the sun search activity and beginning to take the first images. So hopefully in a few hours or a few minutes or less, we'll be getting those first images back. The lander temperatures are all within the predicted range, and basically, like I said, it's about as normal and about as straightforward, or essentially just what we estimated or just what we calculated if everything were going to go right. As far as the rover's concerned, we did get information from the rover. The rover and lander are communicating well. About 98% of the packets are getting through between the rover and the lander, which is excellent. The rover's awake. It was awakened by lander command. All of its engineering subsystems checked out. All of its temperatures are within the expected range. Solar arrays producing power. So we're basically, like I said, doing really well. And we, as you heard over the net there, activated our next sequence, and we're going to go ahead with the remainder of the surface mission. So with that, I'll let Rob talk about entry, descent, and landing.
Well, the little engine that did. And we are just absolutely boggled by the fact that this fairly complex design that we've been thinking about and stewing over and testing and trying to make work really did the job. And You've seen me, and I've sort of been representing the entry, descent, landing team, but really this is a team that all Americans should be proud of because it involves so many people from all over this country of ours. It's from coast to coast. I wouldn't say every state in the union, but a lot of people from all over helped, all over NASA as well as JPL. So it's something that a lot of people can take credit in, and not just me. So with that, I want to let you give a little bit of interesting information about how it went. It turns out that there was a few surprises, not too many. One of the spacecraft landed almost exactly when at the time we predicted it. The signals, as you remember, we had some interesting signals from the spacecraft after we landed. My worst case expectations did not come true. It turns out the spacecraft was very visible after all once it rolled to a stop. The spacecraft did in fact bounce as the spacecraft was designed to do. In fact, it bounced quite high. Maybe I've got actually an accelerometer plot here. If I can pull that one out. That's not the right one. Actually, that is a good one. That's not a bad one for the. There we go. There's a good one right there. Maybe you can pull that one up. You can see. I won't talk too much about the first one. You can see the little tiny spike. That's just an anomaly in how we change the gains of the accelerometers. But that big bump here, that's the deceleration of the vehicle as it went through the atmosphere. Soon thereafter, the software under an algorithm that uses the acceleration, the deceleration profile to figure out when to open the parachute. Open the parachute a little bit later than we expected, which is indicative of the atmosphere being a little bit thinner than we expected. We don't know how much. Not too much later, the rockets fired, giving a nice little boost to the vehicle, and then it hit the ground, and it hit the ground a few times. At least there's one bounce there. We think those are bounces. This data was just put together by Dave Gruhl here about literally 15 minutes ago. So we really haven't had much time to analyze it. But there's no question that the spacecraft hit the surface of Mars quite hard. We haven't looked at the orientation yet, but the first time it hit the surface of Mars was about 18 Gs. It bounced again about 15 meters high, we think, which is pretty high. About 50 feet, and then it hit again about 9 Gs of deceleration, and then it flew up again for another 7 meters in the air, and then hit even harder, 11 Gs. And we haven't figured out what that's all about yet, but it might be in the fact that the spacecraft actually spun up as it impacted, and that could fool the accelerometers into thinking it was actually a straight translation. So there's a couple other surprises, and that's it looks like our terminal descent velocity, that's the velocity that we sense with the radar, was about almost 10 meters per second faster. Instead of going about, let's see, I'm going to do a metric conversion. Instead of going about 120 miles per hour, we were more like 140 miles per hour at the time the rockets fired, which is a little bit surprising to us. It means that we don't really understand the atmospheric density of Mars as well as we thought. But on the other hand, it was well within our expectations of how the design was, the design envelopes. So it was just a little surprise. It wasn't a big deal. The other thing is, this is the part that I lost this bet. This lander has 4 sides, as a tetrahedron should. But what's the odds of rolling down in the base pedal, huh? 1 in 4. I picked it was going to do this. This spacecraft rolled to a stop just like this. And we didn't have to open the pedals to right itself as we had designed it to do and tested so many times. So, if people ask, well, how do you right yourself? Well, we don't have to right ourselves. We didn't have to this time, and didn't need these pedals after all, Richard says. So the spacecraft appears to be, the airbag's fully retracted, and appears that the pedals are really open, perfectly flat. It's interesting. The software tells us that these things have happened and did not feel any errors or sense any errors during this process. So it's a very good bet that they really are. But we will get a better indication in the next downlink session when we actually take pictures around the periphery of the lander and see how the airbags are bunched around the vehicle. So that will be kind of the proof of the pudding, but I'm very happy. And I really am not out of a job. It turns out that I'll be working on surface operations with Richard for some time to come. And but as far as the entry descent landing job, we're there, and we couldn't be happier. Thank you. Sure. Thank you. Thank you. Let's see. We have another picture of the some of the temperatures on. Let's see. Not that one. The one we just had. No. One more. No. Actually, how about pull out the landing site picture? There's we've got several.
First one.
I think this is the very first picture we have here to show where we think we landed. Okay, go ahead. That's a good one. Why don't you go ahead and pull that up so people can see? Well, this is where we think we are. And it's interesting to note, our navigators, if you remember, put us in this region early this morning by 7 o'clock. It turned out that we ended up landing a little earlier in terms of, I say earlier, I mean a little bit less downrange of our landing site. Remember, we're coming in from the northeast, going in this direction, working our way past the center of our desired ellipse, and this is where we ended up. We thought we would be down here. Matt can tell you more about what we're going to see if we land in this, if we really are here. The reason this thing got so small, we're not sure why it moved just yet, but it appears that there may have been an atmospheric density differences than what we expected, as I mentioned before. That's one possibility. Maybe other reasons as well, but this information was acquired over DSS 65, is that right, Richard? Yes, and at the SPF, the station in Madrid, the Deep Space Station in Madrid, over a few hours before we went before we got into EDL. So I think we're safely there, and I'm going to let Dr. Tim Schofield talk a little bit about what we might get from a science point of view from this entry, descent, and landing data.
Okay, thanks, Rob. The first picture, thank you. The ASIMET is composed of two parts. One part of the experiment is to understand the structure of the atmosphere as we enter the atmosphere. The other part is basically a weather station on the surface of Mars. And we have now got the first data from the first part of that mission. This slide that's showing now shows you a detail of the acceleration curve that Rob showed you earlier. At time zero, we're at about 160 kilometers. We hurtle into the very tenuous upper atmosphere, and accelerations are building up gradually all the time. Finally, we hit the maximum deceleration peak here at about 15 G at about 120, 130 seconds, which is a height of 30 or 40 kilometers. If I could have the next slide, please. This is the same data, but plotted on a scale which shows our measurements from very high in the atmosphere. From here we have 10 millionths of a G acceleration, and building up all the way as it comes in, all the way up to that 15 G acceleration peak again. And then you have the parachute deployment pulse there. This information is going to let us work out the density profile of the atmosphere from basically all the way out high in the atmosphere down to well below the deceleration peak, down to where the parachute deploys. We then have pressure and temperature measurements below that level also. We have very preliminary data from the landed part of the mission. We haven't deployed our mast yet. It looks as if the temperatures that we're measuring are around 220 Kelvin, which is about minus 64 Fahrenheit. Those temperatures are somewhat warmer than Viking, but the mast is very close down to the spacecraft on the petals, so it may well be that the sensors are being heated by the sun rather more than they would be when they're up in their correct position. So we're looking forward in the next coming hours to getting the rest of this entry data set, much higher resolution. and working out the density profile and hopefully the pressure and temperature profile, and then getting the time series of atmospheric data. It looks as if both instruments have worked perfectly. Richard mentioned this being like a simulation. To my mind, it's nothing like the simulations. The simulations went wrong all the time. From the point of view of the scientists, the data was always getting lost and going wrong, but so far it's been going very, very smoothly.
Okay, you've heard the very first data we've gotten from our spacecraft, or first science data, I should say, and that will help the atmospheric scientists try to work out this entry, descent, and profile of what the atmosphere is like all the way from 120 kilometers down to the surface. I'd like to back up to about 3 a.m. this morning, and show you what we went through in the last few hours prior to entry. If I could have the first slide, please. What you see here is the landing ellipse in the so-called science ellipse in this large yellow. And at about 9:30 last night and later at about 2 a.m. this morning, the ellipse was this white one shown here, which actually cuts through the northern half of this streamlined island. And some of us scientists were there at JPL at midnight to 2 a.m. trying to determine the slopes on this streamlined island to make sure that they were within the tolerances that the spacecraft could handle, to determine if we needed to do a trajectory correction maneuver to try to nudge us into a so-called safer region. And one nudge would have put us over in this region. Another could have put us up in here, which actually looked worse. One could have put us down here, which is definitely worse. And cooler heads prevailed, and we in fact did not do that trajectory correction maneuver. And we wound up landing right in this small piece of this ellipse shown here. And the next slide shows a high resolution, a detail of that. What's shown on this is the best prediction from the navigation team as to where we actually wound up on the surface of Mars. And it's somewhere within this ellipse, and you can choose your pixel, and that's the one we're in. We do not know which pixel we're in, and it may take us a while to figure it out. What also shows on this are the 20 pixel elements that should be visible from a portion within that circle of large hills like this one here. 20 pixels could be seen by the camera if we landed within that red circle. And there's a larger streamlined island to the south. Could we go back one slide just for a moment, please? Back to the one we were just showing. Thank you. This large streamlined island, this one right here, is about 500 meters high, we think, with what may be a boulder bar behind it. This should be visible in a much, much larger region, this red circle shown here. Back to the next one again, that's the circle you see here. And again, here's a small hill. Well, small, that's a building. Small hill with, again, that 20 pixel element that should be visible. Here's a crater that we should see. And so we're hopeful that after we turn on the imager and start taking pictures, which we've actually are doing, I guess, we will see some of these things. What you'll also notice are this series of what we call secondary craters. And if you look carefully at these craters, they have a bit of a herringbone pattern, which actually tells you the direction that the primary crater hit the surface of Mars. And this is ejecta from that primary crater that is now flopping across the surface. And those herringbones point to the south. We believe the primary crater for these secondary ejecta craters is about 60 to 100 kilometers, or that's one guess. And we might be somewhere in the midst of these as well. And there was some worry, of course, that this would be a very rocky area, since that there's quite a bit of ejecta around these craters. Interestingly also is that these craters seems to have captured some of the dark mafic material. If you look at the pictures of Mars that we've shown, there's sort of this reddish material, and then there's this dark black surface stuff. We think that's a dark mafic sand, and we may have the prospect of actually seeing some of that. All of which we don't know what we will see. Again, I don't know which pixel we're in, and we'll just have to wait and see. Okay, now what's next? Within the next half hour or so, 35 minutes, the meteorology mast, the 1 meter mast, will deploy into the upright configuration with the wind mast on top and the 3 temperature sensors, and we hope to get our first weather report from the surface of Mars at about 35 minutes from now. We should be, if we're very fortunate enough to get the high gain antenna, start receiving the very first images from the surface of Mars. And I want to walk you through what to expect when you see them and warn.
All right, the timetable is set, the clock is ticking. 34 minutes from right now, it is very possible we could be seeing the first picture sent live from the surface of Mars in the past 20 years. And that's what the scientists are saying. We're going to go to Moneyline now, and we'll be back at about half past the next hour, or if the first pictures get here ahead of half past the next hour, we'll be back with those as well. John Holloman, CNN, reporting as our journey to the red planet continues.
News and information are essential for today's travelers.
And joining us now from outside the mission control of the Jet Propulsion Laboratory in Southern California is CNN's John Zarella. Hello, John.
Hello, Relitza. Good evening. I have to tell you that the scientists and the engineers saying that they were pleased is pretty much an understatement. They are ecstatic about how things have gone so far. All of the data that they have been receiving so far indicates that everything on the vehicle is working about as perfectly as it could work. As you mentioned, only a 2.5-degree tilt. That's exceptional. And the vehicle is in perfect position. It looks like at this point for them to be able to get the Sojourner rover off of the pedal sometime later this evening. And joining me this evening is Donna Shirley. And Donna, all of these people who have been on this program are really your children, and they're all quite excited about what happened. You know, there is an interesting question a lot of people always have, and get this out of the way. They say, well, why do we go to Mars? And a lot of the answers I've heard is, well, we really go to Mars to study Earth because we want to know what?
We want to know whether what happened to Mars to make it cold and unfriendly and a miserable place to live could happen to the Earth. We'd like to know why Mars lost all its water millions of years ago and where that water went. We'd like to know why Mars lost most of its atmosphere. We'd like to know why Mars is cold. And it's the same thing. We'd like to know why Venus is a hell on surface that can melt lead. If we can find out those things, it might be able to keep us from doing awful things to our own planet.
They really could be critical questions that could be answered about the evolution of the Earth, where we could be heading without much choice, or perhaps our own ability to alter the outcome.
That's right, that's right. One of the things we know about Mars, for instance, is that there's no life on the surface. It's completely sterile. And one of the explanations might be that the atmosphere is so thin that it's just a giant ozone hole. There's no ozone in the Mars atmosphere, so the ultraviolet just comes straight through and just bakes the surface. And, you know, there's an ozone hole over New Zealand in the summer, and the kids have to wear long-sleeve bathing suits.
Now, to this specific mission, we are rapidly moving down about 25 minutes to one of the very, very big events. One milestone after another has been clicked off successfully.
Perfectly.
The next one in about 25 minutes.
Right. The next one is to get the first pictures back. Now, these are not very good-looking pictures. These are going to be little, highly compressed pictures, and that means that to send them back with not too much data, so they come back pretty fast, they're going to take a lot of the data out and just squeeze the rest of it together. So we don't have stuff it on the ground, but we do have a way of decompressing the pictures. But these first ones aren't going to look very good. What they're going to do, though, is tell us whether it's safe for the rover to get off or not.
That'll be and then you will get that panoramic view that the one I guess that everyone is really waiting
Right.
for, that look out over the Martian landscape.
That's right. The color panorama should come back around 6:30, something like that.
So it'd be about 9:30 Eastern time,
Right,
folks on the
6:30
East Coast,
Pacific,
6:30
yeah.
Pacific
Right.
time. And then the rover off the lander sometime later in the evening, perhaps an hour or 2 hours later at the most?
Maybe
not
yeah,
even?
at the most. Because once we know that it's okay, then we'll deploy the ramps, tell the rover to stand up, and if the ramps fit right, if everything's good with the ramps, then bang, we get the rover off, because we want that rover on the ground to spend the first night. We don't want her on the solar panels.
Donna, thank you so much. You've been here with us all day, and we still have quite a few hours, it looks like, left to go this evening
We're
before
permanently chained here.
permanently chained here. So another milestone coming up in about a half an hour or so, that first image from Mars, what everyone will be waiting for. And then as we move on through the evening, Relitza, we will be, of course, getting the color pictures, the rover off the lander, and just an exciting, exciting time yet to come here from the Jet Propulsion Laboratory and from Mars, about 120 million miles away, right?
Something like that, yeah.
Relitza?
Thanks, John. We can't wait to join you again for all that excitement.
Welcome back. It's John Holloman at CNN Center. We're going to take you right now into the control room at the Jet Propulsion Laboratory's Mission Control in Pasadena, California, where everybody in that control room is gathered around a computer monitor. And as you can see, the people in there hugging, kissing, applauding, clapping. The reason they are doing that, we believe, is that the first picture to be seen on planet Earth live from the surface of planet Mars is beginning to appear in that control room. Now, okay, this is the live picture. You can see the excitement on people's faces.
You can hear the excited...
Let's listen to the commentator there.
As Pathfinder Mission Control, as they have been locking on the high-gain antenna, or right on schedule, 4:30 Pacific Daylight Time, and they have indications that the high-gain antenna has located the sun.
Well, this is good news. One of the things that had to happen...
Of course, is essential for transmission of data from the high-gain antenna.
Donna Shirley, you're the Mars Exploration Manager for NASA. Listen to this and comment when you like.
Okay. Well, what's happened is it looks like that the sun-finding algorithm, that is the equation that told the camera to find the sun, has indeed worked. The computer program on board the lander completely autonomously has found the sun, and then they were able to actually point the high-gain antenna, the lander, all by itself, at the Earth, and so we are now starting to get a signal from the high-gain antenna, which means that we will be getting the pictures back.
A lot of cheering and yelling and screaming and attaboy and attagirl going on in this room.
More handshakes and cheers.
We have 4 frames in lock so far.
I suspect that the pictures have started to come in.
Donna, there are a lot of computer monitors in that room, including 2 that we can't look directly into, where the shift leader is looking. Where will the first picture come in?
Well, I don't know which monitor the picture comes in on, but they're supposed to go up on NASA Select right away. So within some small period of time, we should be able to pull them off of the NASA Select feed.
Okay, we have an internet site here that plugs in to the Jet Propulsion Lab, and I believe the pictures are coming in on that internet site right now. We'll check that and pop it up, and we may get it as quickly as the folks at NASA Select get it. We'll find out. And
now, what these...
Go ahead,
Let me explain what these pictures will be of. If you can get down on our little model here, these pictures will be of the edges of the solar arrays to make sure that the airbags are neatly tucked in under the solar arrays and that they're not lopping over onto the pedals and blocking the pedals. And we're particularly interested in the pedal that the rover is on, because we need to be able to deploy the ramps off the edges of the solar panel so that the rover can crawl off on the ramps and get down onto the surface. And that's the next big event after the pictures coming in. Now, these pictures that we're getting are just little black and white images, very highly compressed, just of ugly little airbags and possibly the rover's wheels. So that, and the rover's, part of the rover and part of the ramps that are going to unfold for the rover to get down. So these are not going to be very pretty. The pretty pictures are going to come in at about 6:30. Yep, I bet you a picture just came in.
That's probably an image right there.
Yeah,
isn't
there it
Donna?
is. There it is. That is an image. Okay. Oh my gosh, it's beautiful.
What is it?
Okay, well, we can see a little bit of Mars. There's rocks. There's the airbags just sticking up just a little bit. They look just fine. But we've got Mars. We've got rocks on Mars. And boy, is
that a rover wheel? Was that?
Yeah, that was the rover wheel there a minute ago. Now, I can't tell what this is. Boy, these are hard to see on this little bitty screen here.
Donna, CNN is going to try eventually to get a bigger TV.
That's
Okay,
a solar panel there, John.
See the solar arrays on it? You can see that. And this must be, look at those airbags. They're just beautiful. They're all tucked in very neatly. They're not on top of the pedals at all.
Which really means you're in excellent position to get the rover off.
Excellent position to get the rover off. Now there'll be some more coming in because what they want to do is to take pictures all around the edges of the pedals to make sure that there's no interference.
Will they put them together then in a mosaic, so to speak?
Yes, they will, but they probably won't even bother to mosaic these pictures because what they're going to do is wait for the color pictures to come down. Now that they know the high gain antenna is correctly pointed, the next images that come down will be the color images, and then they're going to make a really beautiful mosaic that'll have color, that'll have the rover in it. The rover will be right there in the middle of the picture, and
now this is, you know, we should be pretty excited. These are the first pictures in 21 odd years from the surface of Mars.
Absolutely, absolutely.
This is a tremendous event unfolding right here now.
And there's rocks right there, so the rover won't even have to go very far to find rocks. I mean, this is just, it's beautiful.
Barely has to go off the limb and get to work with the pedal with the alpha spectrometer, proton, X-ray, proton spectrometer.
Alpha, proton, X-ray spectrometer. Very good.
And
Donna and John,
doesn't have to move very far. Yes, John.
Let me just jump in. These pictures are coming in very rapid succession, it looks to me like. Is that an indication that the high-gain antenna is doing precisely what it's supposed to be? I mean, I've seen 7 different views show up on this computer screen just in the past few minutes while we've been talking.
Absolutely. This means the high-gain antenna is not only pointed at the Earth.
There's a good wider photo.
Oh, wow. That's hard to see, though. Oh, here it goes. This is one of the pedal actuators that you can see here. One of the motors that actually opens the pedal up like that.
Wayne, can you...
Does it look good to you, Donna?
It looks beautiful to me.
Now, John, is the vehicle taking, this is all pre-programmed to take these? You haven't commanded it to do any of this.
We haven't said a word to the vehicle yet. These are all pre-programmed, and there's going to be something like, I forget how many of these, but they're 80-to-1 compression. So if these are this good, you can imagine what the real pictures, when they get in color and full and not compressed, are going to look like.
Compare these, just from what we're looking at, to the Viking pictures.
Right.
I mean, these are probably better than the Viking pictures.
Well, not yet, but they sure will be. They'll be a lot better. Now, see, this here is showing where these pictures are being taken. This little pie chart is showing where the pictures are actually being taken with respect to the lander, so that you can see. Now, here's some, oh, wow, here's some close-ups. And see the airbags. There's a little bit of airbag sticking out.
That's on the right side of the screen, John. That's the airbag and the wheel. And on the left side,
airbag over here.
And what they're trying to do now,
a little airbag.
Yeah, Donna and John, they're trying to begin to mosaic these pictures together. Those two pictures, they appear to be together at this point. So the picture that we're getting is bigger and bigger and bigger, and
very good.
More and more fascinating. Donna, I don't know how well you can see on that tiny little TV set where you are.
Not well.
Yeah.
Not well.
On the left side of the two pictures, there appears to be a little black blob sort of in the center of that picture. Just
this here.
Yeah. Now, is that a normal looking thing to you?
Actually, I'm not sure what that is, but it's too regular to be abnormal.
I see. Okay.
It's probably just, I know what it is. When the panels are latched together, they come together, and if we can look down at our little model, and we can't, it doesn't do you any good. We can't see it. Anyway, when the panels are folded up, they're latched together, and that's one of the latches. And how you release that latch is you fire a pyrotechnic device that pulls the pin out, and then the rover pedals can come apart, and that's what that is.
Yep. This is amazing. I mean,
and look at those rocks. Look at those rocks.
John,
There's rocks right there.
The upper left of that picture on your left, Donna's referring to those rocks that are right off of the pedal.
Yep, I can see them out there. Yeah, we have
I'm having trouble telling what the thing on the right is.
On the right-hand side,
What
is that
this
the
is.
rover wheel that we're looking
think so.
at?
It
No.
doesn't look like it.
No.
It's really hard to tell from this tiny little monitor.
Well, we're going to get more
But it appears
pictures.
to be
and,
rocks.
We're going to get more pictures. Oh, yeah.
That's right. And as we get more, Donna, I was going to ask you before we went into a news conference a little while ago, if this were an ideal world and everything worked exactly the way it was supposed to, how many pictures would we see from the surface of Mars over the next 7 days?
Oh, Lawsy. Lots and lots. I don't know.
Hundreds and
I
hundreds.
don't know how to count them. Hundreds and hundreds, that's right. And now they'll be taking pictures of different objects. So first they'll do a complete scan of the horizon with all 12 different colors.
Yeah.
This camera takes pictures in stereo in 12 different colors.
And the people back at your end are wearing 3D glasses, some of them, to get
That's
the
right.
depth and all on these.
That's because these pictures are coming in stereo.
Could our viewers do the same thing? If they watch these pictures at home, if they had 3D glasses on, could they see some of the relief in the pictures?
No. No, these pictures have to be very carefully processed, and it's a very special, very high technology silicon graphics computer that makes them into 3D. And you have to have very special glasses to see it.
There's a new photo up there
Yeah,
now,
here's
John.
one.
It looks like, is that airbags?
Yeah, that's airbags around the edge.
Around the
Okay, now
edge.
this is of the edge, and see the airbags are tucked in close to the pedal, and there's another rock right there, and that's a light rock. So we've so far got dark rocks and light rocks, which is exactly
What you wanted.
we wanted. Now, I don't know if these are really dark and really light because we won't be able to tell until we get there. Oh, wow,
There you
there's
go.
a real close-up. Okay.
Yeah,
Yeah,
that's a
see,
close-up
this is the edge of the pedal, and it looks just fine to me.
tells me that we have not taken any faults since our last down session.
Little mission commentary in the background there as the folks in the control room with that computer are talking about these pictures. You can hear a lot of background noise there, and we'll continue to listen up as we hear what these people have to say.
If they're making commentary, it's better than my commentary because they can see the pictures better.
Yes, all of the relays are in the correct position. The battery state of charge is at 72.8%. The shunt current is 1.35 amps. Bus current high is 3.25. Bus current low is 3.33. The battery is charging at 0.12 amps. The battery is discharge is 0. Pedal solar array current is 3.37. The bus voltage is 28.8. The battery
Perfect.
voltage 28.96.
Perfect.
The battery temperatures are 18.87 and 19.55. So
All of
everything
these
relative to
numbers
the
are
power
just
system
perfect.
is nominal. The battery
Everything
is at a higher
is totally
state of
nominal.
charge.
Great.
That means all the power system is working right.
Slide ACS. Go ahead, ACS. The quaternion.
Oh, here's
Oh,
Planet Fest.
this is an interesting
John.
sight. People here are watching at the Planet Fest in Pasadena, California, and there's a huge crowd there. Hundreds and hundreds of people are interested in planetary exploration. They are looking at these pictures on a big screen TV, and they just seem to be fascinated. They're not cheering like the mission scientists are, but they are certainly enraptured by what they're seeing on the surface of Mars, as are we all.
John, there are about 2,000 people there, and I don't know if you heard Donna before. She was saying that all of that data that they were reporting says that the vehicle is performing perfectly, the batteries are in perfect condition, everything is in excellent shape.
Yeah,
Temperatures are right on.
I mean, temperature is a big thing on Mars, Donna, because it varies so dramatically from middle of the day to the middle of the night, right?
Yes, somebody told us that it was actually only minus 64 degrees Fahrenheit, which is quite warm for that time of the night. I mean, remember, it's dawn now, and the sun is starting to come up and warm things up. Wow, now that is, what is that? That's an airbag with dirt, okay? Good dirt. So
Good
Henry Moore will
Martian
be
dirt.
very happy. He likes dirt. He likes
Geologists
dirt.
love dirt.
Yeah.
And this is mostly a geology mission, right, Donna? I mean, the pictures are fabulous for us, but the folks who are really going to be able to get a lot from this are geologists who are going to look at these various rocks as the rover goes around and points its looker at these various samples that are there on the surface of Mars.
It's actually more like a sniffer.
Yeah.
And so as well as looking, it's going to sniff them. And so we'll not only know what they look like, but what the chemistry of them is.
Little chemistry set in space.
Oh.
It's just amazing.
Okay, now there's another actuator. So all this stuff is showing that everything is just perfect. I mean, it looks like that model in the auditorium.
No kidding. There are a couple of the wheels. This is what happens, you know, when they open the cargo bay on the space shuttle. They do a survey.
These are the rocker bogies. Okay, what we're seeing here is this must be the back of the, now that's a solar panel. Oh, there's a wheel. See that circular shiny thing there up in the upper right corner?
We had seen one just a minute ago as well.
Yeah. Yeah, we've seen at least the 3 wheels on one side, Donna, go by.
Okay, now this is some airbags. Okay, this is in between the pedals here. I can't really tell what these look like.
This is Mars Pathfinder Mission Control.
I can't tell what that particular...
Oh, look at that, Donna. That's looking out from the rover.
Okay, all right. Rocks, lots of rocks. Beautiful.
Looks kind of like Mars.
Oh, there's a big rock. There's a big rock.
Yep, right up at the upper right-hand corner of your screen.
Yeah. Oh, boy, is the rover going to love to get its spectrometer on that one.
Yeah.
Woo.
Folks at Planet Fest are up on their feet now. It's like the World Series out there, up and applauding.
Oh, this is incredible. Just look at that. And it's an easy trek over to that rock, an easy trek. So we can send the rover right over there. And the rover can put a spectrometer on that rock anywhere.
That's a nice picture, too, a nice wide picture.
Oh, yeah. Oh, look, there's a big, oh, those are big rocks. Those are lovely. Now, see, this is the advantage of the airbags. Because if we landed with propulsion the way that Pathfinder had, we wouldn't have been stood off from the rocks like this. We could have been right on top of them. But the airbags have stood us off from the rocks. And so those airbags have done their job.
And also, if you were using a rocket to get you down there, a lot of what was on the surface would be blown away by the rocket blast, right? I mean, this is pretty much undisturbed.
That's true, except for where the airbags have actually dragged in. But that's actually good because that turns rocks over. And we'd like for the rover to be able to put its spectrometer against the unweathered side of the rock. So we'd like to turn rocks over. So if the airbags have turned a few rocks over, we're going to be very happy. Although we don't expect to find any worms under them.
Donna, I can't tell if you have just planned this so very well so that everything that happens is just exactly the way you want it, or if it's just a very lucky night for you and your Pathfinder team. I think it's probably the former.
Well, a lot of it's the former, but a lot of it has to be the latter because we don't know what Mars is like. I mean, we were diving into an unknown terrain. It's like if you were going to Acapulco, you know those divers that dive off the rocks?
The pearl divers,
and they've done it before, so they know where they're going. But if you went up the first time and you didn't know, you'd probably kill yourself, right?
Yeah,
so this is just like diving in where we don't know diving into the pool where we don't know what's under there. And so there's a lot of luck to it that we have, as well as just superb engineering and science. Now there's the rover. Okay, this is the solar panel of the rover. And you see on the top edge, there's a close-up now, that bent part that's got a double bend, that's the antenna.
Yeah.
So that means the antenna's locked in properly. The solar arrays look good. There's rocks right there. Everything is looking terrific.
That was looking down right on top of Sojourner.
Right on top of Sojourner, that's right. Now, she hasn't stood up yet, so when she stands up, then it'll be somewhat different view.
Donna,
and this is...
approximately when will Sojourner stand up, and how does that work?
Okay, as soon as these pictures are in, if the scientists put them together and determine, and the engineers, and determine that it's safe, oh, there's some airbag stuff all folded up, and I don't know where that is. So I don't know if this is a problem or not. But if they determine that the airbags are in good condition, then they'll right away send the command to deploy the meteorology mast and for the rover to stand up and for the ramps to deploy. Then, after they deploy the ramps and the rover stands up, they'll take another picture. That's when they get this really nice color panorama. Yeah. That is what they'll make the decision to send the rover off or not.
Now, how long do you anticipate it to take for all of these postage stamp-sized pictures, as others have described them, to come in? I mean, how long before they have the mosaic ready to show us?
Well, I really don't know. I think it will probably be another few minutes.
But we're getting to see these things absolutely the first, just as they come out on the computer.
Absolutely. We promised that to the world. We said as soon as we get these pictures, everybody's going to get to see them just as soon as we do. And this is really unprecedented because always before, the scientists have had rights to the data, so they could hold the data for a long time until they felt comfortable releasing it. And Peter Smith has taken the risk of just putting it out there without knowing what it was going to look like, and that's quite courageous for a scientist.
All right. Oh, well, listen, Donna, we've got a picture now of your crew in Mission Control doing the same thing our viewers are doing all over the world now, looking at the TV set as these pictures come in. Our viewers actually have a slight advantage over the people in the control room in that we can take the little pictures and blow them up to fill the entire TV screen. It's a pity you don't have a big TV screen like I do. But,
well, all I have is this scrunchy little monitor. Oop, there's some rocks. Okay, now, see this rock? It's all pebbly looking. Now, Viking had rocks, the Viking images had rocks that looked much like that as well.
Yeah.
But then there's a rock beyond. I'm not a scientist, and so I'm just blithering here, but the rock beyond doesn't look to me like it's as rough. And what we want in this landing site is to have all kinds of different rocks. And I bet you we're going to get them.
Sand looks as if it's almost windblown there.
Right, it probably is. In fact, that looks like a little dust drift to me.
Right.
But again, we're not scientists, so I'll defer and let the scientists talk about what it really is.
Well, it is a fascinating picture, Donna. I'm looking at it as closely as I can here, and it looks sort of like a lava rock, like you might have in your garden, or if you went to Hawaii or someplace. Here's another picture. I think probably the other side of the same rock.
Yeah, that's the other side of that same rock.
Yeah. And it looks almost spongy. I don't know if that's what you said or not, but it appears to be lying on a beach with very fine powdery sand in this black and white view.
Right. Well, actually, that's what the Viking 1 site looked like, and the Viking 2 site as well, is they had rocks like that with wind-blown sand that had blown up against them. And so, at least to first order, this doesn't look, all that different than Viking, except the rock on the right looks to me lighter than the rock on the left.
How far away is this landing site, roughly, from the Viking landing site?
Oh, it's well over 1,000 kilometers. So it's really a long way away as planetary distances go. It's and we expect the terrain to be quite a bit different. We don't think that the Viking landing site, that's Viking 1, was in this river valley.
Now, Donna, you say in this
mostly crater.
Yeah, in this river valley. Any idea how long ago it was that a river was flowing down through this area of rocks here?
No, and that's okay. There's ooh, I don't know what that is. We really don't know. The best we can do is say that by age dating, that means by counting the number of craters. If there's fewer craters, that looks like a hole to me. It looks like something that's been...
A depression, kind of, yeah.
A depression. Now, maybe that's where the airbags dragged a rock out. That could be.
Uh-huh.
That's just a guess on my part.
Well,
there it is. I lost my train of thought. What were we talking about?
That's what we're seeing in the picture.
The age of, the river.
The only way you can tell old things is on Mars, because we don't have a piece back yet to age date. Okay, now this is a calibration target. See that circle? Mm-hmm. And so that's going to help the camera calibrate its color. And so that's why we're going to get the color to be right on those first color pictures.
Sort of like in TV. We point our camera at something white and push a button and it gets all the other colors right.
Right, and this is sort of the same sort of thing. Now, the age of the river valley that we're in is not... Wow!
Look
at that. Oh, that's great. Oh, look at all those rocks.
Looks like Arizona to me.
Sojourner's going to have a field day. This is just beautiful.
What is that?
Oh, look at that. There's a flat top rock.
Flat top rock.
Wow.
This is amazing.
This is amazing.
Now, Donna, this looks like a piece of airbag over here.
Yep. That's what they're really trying to do, is take pictures of airbags, but every now and then they goof up and get a really nice rock picture.
Wasn't that spectacular? I mean, it really did. It looked like Arizona with little tumbleweeds and things. Obviously not tumbleweeds, but ooh, look at this.
There's another one. Oh, wow.
There's something. See that rock? That looks like a big one.
Oh, my gosh.
Another
that's
one here,
big one.
and a
now,
3 or 4
there's
here.
Your airbags. Airbags save this.
Yeah.
If we tried to land propulsively in this area, we would have been creamed.
Apparently, we were not creamed.
Nope. Tom Rivellini and his crew really did their job.
Wow.
And ILC Dover, I should mention that ILC Dover was the contractor that built the airbags for us.
When I talked to Tom Rivellini this afternoon, he had said to me, he says, I wasn't worried about the airbags. I was worried about everybody else's systems. I knew they'd work, he said. And they did.
Yep, they did. Really remarkable. They were the thing that was making everybody nervous. You know, everybody call in and say, oh, those airbags, isn't that dangerous? But it looks to me like they just worked perfectly.
The landscape shot showed some fairly
Well, the
sizable
pictures keep
boulders
on
against
coming.
the
This is,
system.
boy, I'm going to be able to tell my 4-year-old that I was here on this night. Look at this flat rock here.
Wow.
Isn't that interesting?
A huge rock.
It
A
went
flat
away.
rock. Oh, my gosh.
I don't know if this is a rock or an airbag,
Flat
this
rock.
piece here.
Oh, you know, gosh, that's just, I don't know, that's airbag.
Yeah.
That's airbag.
But that quick picture of the flat rock, it looked like sandstone almost.
It was incredible.
It was weathered on the
Now,
top.
we know that what happened was that these rocks got dragged downstream, and so it could be that they got dragged so hard that it abraded the top of them off, or it could be that they were actually from a flat part of the terrain and were kind of floated down. And so we just don't know. Boy, are the scientists going to have fun with
I was
this.
going to say, this area is going to be a
There's
field
gonna
day,
be,
isn't it?
yes, there are going to be happy scientists.
And it'll take years to figure out what all this means, right, Donna?
Yes,
I mean,
yes,
they'll be
it
looking
will.
at this, and people will do their doctoral theses on things like this.
For years and years. Now, we have actually, with the Viking data, they spent 20 years analyzing it. And we can spend 20 years analyzing this data, too.
Whoa,
You
look
can
at
rewrite
this.
everything.
Look at this, you guys.
Oh,
Does that look like a hill or
wow.
what
See,
is
there's that flat rock again.
it almost looked like the contour of
Yeah.
the land was going up.
Well, that's what they thought they might actually be able to see, is, you
A
know,
rise
something
in the
rise in the
distance.
distance, yeah. Now that looks like a wheel. Oh no, I think that's the APX. I think that's the spectrometer on the back of the rover, but I'm not sure.
Oh, that's the sniffer. No, there's a wheel. You can see
Yeah, there's a wheel. Okay.
the central area
Looking
in
good.
that.
There's no airbags on top of anything. You know, the wheels look really good. I can't see the restraints.
They're cheering.
We're getting cheers. Is that cheers from Mission Control or cheers from
the Planet Fest. I can't tell. We're hearing
Okay.
things from all over right now.
Oh, wow. There's Sojourner. Look, you can see the little teeth on the wheel. And
Yeah.
the rocker
bogey.
bogies are looking good there. Yeah, that's the little teeth. That's what somebody's pointing out.
Yeah, I'm working the little illustrator.
John with his
back
Oh,
here.
that's
illustrator.
John. Okay, okay. And then the rocker bogey is that thing full of holes. Okay, there's another one.
Yeah, all
Boy, I
right.
wish we had better light.
Coming soon.
That's
It'll
the wheel again.
Yeah, that's the wheel again. You're right. With the axle, the shiny part with the axle.
There's two wheels, Donna. There's one visible there and one visible there.
Yep. Looking good.
Same picture
Now,
again, I think.
When the rover gets off, then we'll be able to take similar pictures of the lander from the rover,
Yeah.
which will really be cool.
We're currently seeing
Okay,
some
there's some of the tracks. As the long skinny thing is the tracks.
Oh, that's the
rover
the
sitting on
red
the pedals.
carpet that that will roll
Right.
out for it. Yeah.
Well, I do not believe they have unrolled the ramps yet, and
No.
I can't really spot the ramps.
Well, they wouldn't do that until they were sure that the bags were out of the way, correct?
That's right.
Yeah.
That's
Donna,
right.
what are
So
these things?
pictures-
Look like dominoes. Can you tell me? It appears they're on the
You
edge
know,
of the airbag.
I can't tell you.
Okay.
I don't know what those are.
Hope they're from Earth.
Oh, yeah, they are. I'll guarantee. Okay, now there's nothing for Earth. That's from Mars. And there's a long, wow. Boy, I wish I could see these better. Would you guys get better monitors, please?
Yeah. With all the money we're making on this, Donna Shirley, we'll get you a big TV for the
All
for the
right,
future.
get me a big TV. Yeah, I want a great big monitor.
There's
Okay, now
there's
what
some
is
more of
that?
these domino-looking
Yeah.
things.
Okay, well that must be part of the structure. I don't know what it is.
Yeah. When it's put all together with the rest
See,
of them, I'm sure.
and I
we'll
don't know
back.
what those spoke-looking things going on out
These.
either because I can't quite see. You know, I don't know the perspective.
Yeah.
Yeah, I don't know what those are.
Okay. As the
never
pictures
seen-
continue to come in, Donna, we're going to take a quick local cable break, and we'll be back at the top of the hour with more of this. What a night. We are seeing history being made, ladies and gentlemen, from the surface of planet Mars, live pictures being beamed back to Earth. Pretty soon they'll be put together in one big old beautiful panoramic view of the planet. And we'll be here to bring the whole thing to you as the evening continues. Stay with CNN.
Looks like the journey is over. I'm Leon Harris here at the CNN Center in Atlanta.
It's a pretty exciting day here today. I'm Joey Chen. It started with a bounce, a roll, and a great whoop of excitement. John Holloman has been following up all the activities here today as we've been following what the Pathfinder's finding on Mars.
A historic.
I'll say, I mean, we need to bring our viewers up to speed here, so I will read a few words. Shortly after landing, the Pathfinder started sending radio signals back to Earth, letting its handlers know the lander was okay. And then about 30 minutes ago, we started getting these pictures. They're being beamed down as fast as the Pathfinder can send them back down to planet Earth. These are rock formations near the planet Mars. And this picture is just coming down. We've seen a picture similar to that in the past few minutes. The folks at the Jet Propulsion Laboratory describe these pictures as being postage stamp size. We are lucky at CNN. We have a machine that will blow up a postage stamp to fill your TV screen, and that's what we're doing with these things as they come in. What will happen over the next 30, 40 minutes is all of these small pictures will be stitched together electronically, and then, look at that. Isn't that something? That's a Mars view, and if you look up in the upper left-hand corner, sort of on the horizon, there's a hill. That's going to help them orient which way the Pathfinder is pointed, because they, on the earlier big, wide pictures of Mars, they were able to see things like that hill.
So they did identify that particular hill?
They haven't yet, but they will be able to, almost certainly.
Now, John, does the Pathfinder look for the pictures in any particular order? It just swings around and takes arbitrary angles?
The thing that these pictures are being taken for has very little to do with looking at the surface of Mars. It has to do with making sure everything on Pathfinder is working. It's mostly to check the airbags, to make sure they've deflated and gotten out of the way, and to check the various pieces of Pathfinder, the wheels. There's a series of devices that cause it to raise up off of the point where it's sitting, and just occasionally what they will do is send down these fabulous pictures of the Martian surface. That's going to tell them where to send Pathfinder. Right above the word news on your screen right now is a flat rock. Why is a rock on Mars flat? Scientists are going to be worried about that for a while. There are a couple more that are somewhat flat. And you can see out here in this area, there's a whole bunch of very large rocks.
Good-sized boulders.
Yeah, pretty good-sized boulders, based on where the camera is and the kinds of things it is able to see.
Now, do you know how many of these postage stamps they need to put together one picture?
A couple, I think it's about 100, and they have sent in almost 100. So what they're going to do with them is take them, get them together, make them into a mosaic, sort of like a mural put together from a bunch of little small paintings. And it's a little bit of a jigsaw puzzle, but as soon as the puzzle is together, we will see actually two separate pictures from this. The first picture will be a narrow-angle view looking just down at the rover, the Sojourner. And the second picture will be this bigger panoramic picture, the suck-in-your-breath picture. And we've been seeing the little pictures of that, like this piece right here. Lower left of your screen is a piece of the airbag. And so they can say, well, that's an airbag picture. And then you see this. These are being apparently sent back in different wavelengths. It looks like the same picture in different lighting, but it's just based on how they're taking the picture.
Well, I know this may be the first wave of photos, but have you heard any gasps of surprise yet?
I have, from among other people, Donna Shirley, who's the head of the Mars Exploration Program for NASA. Donna, you and John Zarella are just looking at these as I am, and Leon and Joey, and our millions of viewers around the world right now. Gasps of surprise. What's the most surprising or most exciting thing you have seen so far in this picture show?
The most exciting thing is the stuff on the horizon. Viking was and both Vikings were landed deliberately in a very boring place so that it would be flat and safe. And,
there it is right there.
Okay,
it looks like hills in the distance.
Yeah, and the hills in the distance, Viking couldn't see anything like this. And in fact, we saw one that's obviously a hill on the other side of the horizon. So this is extremely exciting because this is actual topography that's nothing like Viking saw. And in fact, is much more like the Channel Scablands in eastern Washington that are the analog for this. And that will help us learn about what happened at this place.
You can see in the corner of almost every picture, John, almost in the corner of every picture, you can see the outline of a hill or a mountain in the distance.
Right,
fabulous.
Spectacular.
Yeah, it looks kind of like Arizona, New Mexico, something like that to me. But when you did your analysis, you thought eastern Washington is what you'd be seeing, huh?
Well, eastern Washington is where these giant floods happened 13,000 years ago.
Yeah.
And they ripped rocks out and carried them downstream and left these islands, like we saw in when the pictures we were looking down on the landing site. Remember, we saw those stream-shaped features? Those are islands, and they stick up. And I think what we must be seeing is some of those islands, because where we landed, we know from the last press conference that those red circles in the picture where you're looking down at the landing ellipse, those circles showed features that we should be able to see sticking up above the horizon. And sure enough, we're seeing features.
Yeah, let me ask you quickly, if I can, about that landing ellipse, for folks who might be just joining us this particular hour. How close did Pathfinder come to actually hitting exactly ground zero where they were aiming at?
Well, certainly within a few tens of kilometers.
Well, they had already said this was a hole-in-one where you landed. It was like hitting a golf ball at JPL and putting it in the cup in Houston.
Right.
So
only you get four. you get 4 strokes. And so it was a birdie.
That ain't too bad. That ain't too bad.
Not too bad. It was perfect.
No.
I mean, everything has been perfect about this mission.
Now, Donna, there are people now in your control center at JPL looking at these pictures with 3D glasses.
Right, that's Brian Cooper. He's the rover driver.
Yep. Okay. Now, what is he seeing in 3D that we can't see on television?
Okay, what he's seeing is three-dimensional. Those goggles he has on are 3D goggles. And he is seeing these first pictures, and he's trying to figure out whether the airbags are nice and flat and tucked in or whether they're sticking up. And when we just look at that with our bare eyes with a regular monoscopic television set, it's very difficult to get scale. With these 3D goggles, he can actually see the scale, and he's going to determine whether it's safe or not to deploy the rover ramps. That's his job at this point.
And John, he was telling me the other day that he will be able to place his mouse and click on the mouse, move the rover where he wants it to go, and then the rover will go there.
That's right. What he does is actually, in order to direct the rover where to go, his mouse can leave lawn darts. He leaves little icons of lawn darts. So he puts lawn darts where he wants the rover to go, and he based on the rover icon. So he's got all kinds of tricks he can do with that workstation. Brian, incidentally, wrote all the software for that workstation. He's the guy who programmed the workstation.
It sounds like he's got great mobility on this thing. When he is able to start moving it, I mean, what will he direct it toward? Are you aiming at a specific target, specific things that you want to see?
The scientists are going to be going bananas because there's so many targets. They're going to be, clawing and scratching and fighting each other to choose the target. Actually, they're not. They'll be very civilized. But there were so many fascinating targets in there that the scientists have different areas of interest. Like, say, some are interested in sediments, and some are interested in volcanoes ejecta, and some are interested in crater ejecta. And so they're going to be arguing about which rock to send the rover to.
John,
they decide.
Yeah. There are people all over the country and all over the world who are watching this. The National Space Society has taken over the Planet Hollywood nightclub restaurant in Washington, D.C. There are big screens there. Karen Rugg is there by one of those big screens, and it has a pretty big crowd. Karen, thank you for joining us. It's nice to see you. What's the atmosphere like that? Is it just wild and crazy?
Well, it's wild and crazy right now, John. We've got a restaurant filled with people. Some of them knew what was happening today. A lot of them were really thankful we put the images up here at the restaurant. I've been talking with couples from all over the world, and they're sitting there going, this is the neatest thing, and every time someone there says wow, they say wow also. But we're happy that we could bring the images here tonight.
Right, looks like a very big crowd and an excited and interested crowd. I've been to Planet Hollywood in Washington, and usually people are in their own booths doing their own thing with liquid refreshment, but people seem to be up and around and looking at stuff behind you there.
Yeah, actually the people, when the first images came up, and we've got at least 15 very large screens here, and when the first images came up in the bar, everyone stopped drinking and they were taking pictures of the images on the screen in the bar. And, people are stopping eating and watching and asking questions of the National Space Society people we have located here throughout the restaurant. More of them are going to come here later tonight. We didn't expect everything to go as smoothly as it did today, as we found out. So we're still waiting for some people to arrive before the fireworks go off here in Washington.
Yeah, and the fireworks show in D.C. is about an hour away now. But we're going to go back, Karen, and let you and the people at Planet Hollywood look at these pictures as they come in from Mars. We've got a couple of different things that are going on. The rover driver is apparently sort of plotting his rover on the computer screen as he looks around at the first images to come in and gets ready to drive the rover off of the Pathfinder lander. Yeah, he's looking at the ramp that the rover will be traveling down. And from here, at least, the ramp looks pretty good. I couldn't tell if that was a simulation or the ramp is beginning to roll out. Donna Shirley, do you know at this point?
Well, when the ramps roll out, they roll fast.
Yeah.
It's not a beginning. They just go kerplunk. They're just like the children's toys, the party toys that you have at New Year's. You blow on them, and it goes zoop. And except they don't operate with air. They operate because they're spring steel. And once you release them, then they just unroll all by themselves.
Now, let me ask you something.
Covered with, yeah,
I'm sorry, Donna. This is Leon back in Atlanta. I heard you earlier talking about this picture we're seeing right now. You were saying something about this picture being used to calibrate the cameras for the color. Is that correct?
Yes.
Now,
yes.
Can you tell us a little bit more about that and when we can expect to see some color pictures coming back?
You're going to be seeing the color pictures at about 6:30. The way everything is going, they should be coming back just about at 6:30, which is when we expect them.
Hour and a half from now.
Yeah,
Okay.
okay. We're going to take a quick break. The pictures continue to come in from the surface of planet Mars. The experts are there, and people are looking at them from all over. We'll take a little break. We'll come right back and show some more. Quite a night. All right. Stay with us. How about this? Our journey to the red planet, which we gave maybe 50-50 odds of being a success, is a big success. It continues. We're going to go around the country, go around the world, get reaction to this. This is mission control for the Pathfinder project in Pasadena, California, where they're now beginning to mosaic the various pictures together. This is a picture from the Planet Fest in Pasadena, California, where there's a crowd of about 600-800 people who are looking at the pictures coming in from Mission Control just across town at the Jet Propulsion Laboratory. We also have big screen TVs arrayed at other spots around the United States. There's one in Washington, D.C., where Karen Rugg of the National Space Society is standing by with reaction from her location. Karen, there were a lot of these pictures that came in. What did you think as you saw the first one and some of those terrific panoramic shots of Mars?
We thought it was absolutely tremendous. I mean, the quality and the resolution of the images, and as everyone there was commenting on the types of rocks that we were seeing and the types of material around those rocks, everyone here was asking, what are we looking at? What are we looking at? And especially also when we saw the airbags deployed. I mean, it's so exciting. And the fact that they came in so quickly and there were so many of them. I mean, what a change from 20 years ago.
No kidding. Remember the first Viking pictures? They kind of unscrolled line by line by line across the TV screen, and it was kind of funky. You had to, it was like a slow-speed computer versus high-speed computer, you know?
We have our online manager here, and he has his computer hooked up to an ISDN line here in the restaurant, and he's down in a corner. We're going to meet him a little bit later, and he's got some of the images up at the same time, and he's surfing the web and taking a look at what's there. Got people looking over his shoulder, and they want to know what's going on. They want to know more about the mission. So there's a lot of information exchanging going on here. We're going to try to beat the celebrations we saw earlier at Mission Control, but we're not sure if we can do that.
Karen, good luck. You have to do a lot of hugging and squeezing if you're going to do what they were doing in Mission Control
definitely.
at the JPL. Okay, John Zarella, Donna Shirley are standing by in Pasadena, where it's still a beautiful sunny day. I hope it's gotten a little cooler for you guys. It was really hot there, middle of the day.
We moved under the shade. I've got to tell you, John, that they're doing a tremendously brisk business here right now, selling souvenirs, T-shirts, and this is the hottest item anywhere in town right now. It's a Hot Wheels that took about 4 or 5 months to design, and your design engineers worked on this. And
hold it up a little higher,
it's amazing.
John. Let's see if we can get
there
close
you go.
to it.
You can see it there. I'll hold it. I'm shaking. I'm so nervous with how exciting the day has been so far. But it's tip it down. Tip it down. There you go. You can see it's got a lander, and it's got the rover, and it's got the back shell. They can't keep these in stock here in Pasadena. They've gone through thousands and thousands of them, and I understand that there's a limited edition one made in like silver coming out in them.
It's gold, actually, 24 karat gold plated. on a silver base.
I've been
You just
looking.
can't keep them in stock.
Yeah, I've been looking for this particular item for about 3 weeks, ever since I knew that all of us were going to be working together. I went to
What's
every...
it worth to you, John?
We'll negotiate off the air, John, you know? Jay Holloman has a birthday coming up in about 5 days, and we need to talk.
Yeah. Well, now that Pathfinder has worked, these things are really going to be popular. They ain't seen nothing yet.
Yeah.
John, you know, one of the amazing things that Don and I watching these pictures, the really fascinating thing of these hills and mountains in the distance, that's just unbelievable.
Yeah, oh, it's just spectacular.
Hey, Donna, let me interrupt you. Look at the TV set over there, and this is a...
That's Brian.
That's Brian. It looks to me like the ramps are out.
No, this is a simulation. Right now, and this is showing what it will look like if the ramps are unrolled. And what he's going to do is to take this picture now and try to place it in the scene so that he can see whether when the ramps are unrolled that they'll be okay.
Oh, so he's just testing.
This does not mean that the ramps have, yeah, he's just testing. He's practicing. Okay. And the wonders of modern computer science are that we can actually simulate all these things, and we don't have to just fire blind. We can actually simulate what it's going to look like.
They're actually unrolling. It looked as if they were unrolling a little bit there. Or...
Right. No,
yep,
see,
there it is.
There they go. But that's just a computer simulation.
Right, correct.
And he can take the data that was sent down earlier and unroll those things over the real data from the Martian surface.
That's what you're seeing right now.
That's what he's doing right now, John.
That's what he's showing right now, is he's now going to simulate what these ramps look like when they deploy. I don't know if you'll be able to see it very well from his screen.
It's fascinating, and we're getting a pretty good view because our crew out there at JPL is zooming in on the TV set or the computer monitor to let us see just what Brian is seeing. And,
now it looks very fuzzy to us because it's a 3D display, and we don't have 3D goggles, so it's going to look kind of funny and fuzzy. Also, he does these mosaics, these frames. He does not attempt to join them up seamlessly because then they would get distortion. So it's more important that they be accurate, accurately reflect where things are, then they look pretty. They don't
Periodically, he lifts his glasses and then he puts them back on. Why does he do that?
Well, that's kind of so he can get the perspective of where he is. It just helps him see the stereo better once he's seen what it looks like without it. Kind of like
there's his lawn darts that you were talking about. He had a whole bunch of lawn darts there.
That's right. That's right. He's got lawn darts.
Explain that to us again, Donna. Those lawn darts are for what?
Okay, all those lawn darts are is Brian's really cute way of marking where things might happen on the surface. So once he puts in a lawn dart, it just gives the coordinates of that point on the surface. His Silicon Graphics workstation gives the coordinates of that point. And the lawn darts are just his way of being able to visualize where that point is exactly. And where they penetrate the apparent ground or the apparent plane of the ramp in this case is where the coordinates get read out. So there's Brian without his goggles.
Well, he's a nice looking guy without goggles, isn't he?
He is.
We are, by the way, to let everybody know, we're not getting any more pictures down from the surface of Mars right this minute. As pictures were coming in a few minutes ago, we recorded them on tape, and I think it's probably going to be possible for us to play back some of that videotape with the great pictures from Mars on it, as soon as we can get it together here, and maybe we can look at them at greater length than we were able to when they were coming down live, because some of the great panoramas were only there for a second or two. Yeah.
By the way, what you're seeing here is scientists. Those are scientists. Remember I told you the scientists were all going to crowd around the TV screen and argue about which rock to go after?
Yep.
There they are.
That's what they're
doing. It right in front of you.
Well, there's one guy looking the other way. I think he may be a reporter.
No, there's no reporters up there.
All right. I had heard, Donna, there'd be about 100 scientists in this room in Building 230, not far, about 100 of them in
Packed in like mackerel.
It is not a big room, John, by any stretch of the imagination.
And so we don't have any room for reporters, even if they're very thin. We don't have room for them. Boy, not if they're John size.
No, that leaves me out for sure.
Yeah.
I see Wes Huntress from NASA, the assistant
Right, well, he counts because he used to be a scientist before he was an administrator, so they let him in.
There's another one of those first photos, but we've seen those before. That's the wheel again.
Well, look down, though, here. See the circles with the
circle in the middle, John.
The red circle, and you see how there's a little wedge? That tells where the camera's pointing. So you're getting a lot more information now than we were before. I'm not sure what the run on the right is, but Okay, so when you see a picture and then you see the display down below, that shows where the camera is actually taking that picture. And that helps them with the mosaicing. It also helps Brian visualize. Oh,
all right, listen,
wow, that's beautiful.
it's fabulous. We're going to come back and look at more of these, Donna. We've got them on tape and got them ready to play back for you, and we'll be able to keep them up on the screen a little longer than they were when we got them in live. But we're going to take a break first and get our act together, ready to do that. Stay with CNN. We'll continue with our return to the Red Planet in just a moment. Our interplanetary picture show continues with John Zarella and Donna Shirley at the Jet Propulsion Laboratory in Pasadena. We're going to continue to show you the pictures, Donna. We'll slow them down. You and John talk in our final moments here, and we'll remind our viewers that 65 minutes from now, we'll be back with a NASA news briefing with the first color picture from Mars. If we get the color picture ahead of that, we'll come back earlier. And then 2 hours and 4 minutes from now, all of us will come back together for a half-hour special, showing you everything we've been able to gather so far today on this fabulous, mind-bending story. Donna, John.
We've been looking at these photos, John, and able to see the mountains in the distance, and now the close-ups, Donna, of the rocks.
Right. It looks like there's some sand drifted around the rocks, very much like what Vikings saw. These little dunes.
One looks lighter than the other, actually, doesn't it?
Right,
there?
it does. Now that could be because it is lighter. It could be because the camera's got a different sun angle. It could be because there's dust on one of them and not on the other. So we really won't know.
There's that hill in the far distance.
It's a mesa in the far distance, and that could be one of these streamlined islands. And it also looks like there's a kind of a hill over to the right.
Now it's not likely that Sojourner can get that far away, is it?
Well,
yeah. You don't know.
Not easily.
Not easily.
That mountain could be 10
miles away.
long
Ways away. That's right. That's right.
So we'll be very happy if Sojourner just gets to some of those absolutely luscious.
There's one that looks like the flat, a flat rock formation.
This may not be a flat rock. What it may be is a dike, what they call it. It's a little trail of sand. And that looks to me more like a trail of sand, but I'm not a scientist. Now, this thing in the foreground, this white thing, is definitely.
Doesn't it appear, there's no question there is going to be a wealth of opportunities for the geologists to look at those.
Rocks. Now, there's a kind of a flat-looking rock, but see, those are perfect. Those are just the kind of rocks that Sojourner can get the spectrometer on, and without even having to travel very far. Now, this would be very difficult for Sojourner
to go. Look at that.
Donna and John, we're going to have to wrap this up for a little while.
Okay.
But we've got more pictures expected. We've got the big color picture 60 minutes from now. We'll come back and share that with you. And then 2 hours from now, all of us, including astronaut Story Musgrave, who joined the space program to walk on Mars and hasn't gotten a chance to do that yet, will be with us to offer his thoughts as we continue with our live coverage of this very remarkable journey to planet Mars. For Joey Chen and Leon Harris, I'm John Holloman. Thanks for being with us. It ain't over yet. More great pictures coming from Mars.
The following is CNN's coverage of a live event.
Hi, it's John Holloman at CNN Center. We're interrupting Larry King Live for live coverage from the Jet Propulsion Lab in Pasadena, California. We're about to see the first full-color panoramic picture of Mars in 20 years, maybe ever. And there's a slight problem with the Pathfinder lander. We're going to go live to John Zarella at the Jet Propulsion Lab to talk about that. John, hi.
Hi, John. Yeah, we're not going to give away the secret on that picture, but I hear it is just spectacular. But we do want to tell you, and Donna Shirley is here with me, and she can explain with our little model here very quickly exactly what the problem is.
Okay, the lander is lined up in this direction with this pedal pointing almost due west. There are airbags which are sticking up on either side of the pedal enough that they're concerned about being able to deploy the ramps. So the plan is they're going to tilt the pedal up about 45 degrees, retract the airbags some more, and then lower the pedal back down just to make sure there's no danger to deploying the ramps.
And at that point, then they would unfurl the ramps.
Right.
Is there a chance that we may not get Sojourner off tonight?
There is a chance that we may not, because they have to take more images to verify that everything's clear. It's possible we could. It's possible we don't.
We're quickly approaching Martian sunset,
right,
correct?
Martian sunset is, well, we lose the signal at about 10:20 tonight, p.m., our time. And, but there's a lot to get done before then, and it takes a while to do these things, send the pictures back, and so on. So it's kind of iffy if we're going to get Sojourner off tonight.
Now, John, we don't want to steal all the thunder of the press conference, but we understand, again, as I said, that that color photo that we are about to see will give you a panoramic view of Mars that is something spectacular.
Spectacular. It is a gorgeous picture.
And we're going to go to the presser right now. We should get it quickly.
Okay. I want to see it.
The IMP camera, which is taking the pictures you're about to see, has a personality. And if, in the first slide, let me just show you for a second what it looks like. It has two eyes, spaced about twice the human eyes. The eyes even have eyelashes to keep out dust. And you can see it is smiling. It is happy to be traveling to Mars. In all the pictures from EMP, the eyes of the camera are our eyes, and in that sense, we're all on Mars. We're there together. You might say that the people of Earth are the soul of this robot. So for the first presentation of images, forget about the engineering and scientific aspects. They're very important, but open your imagination to the experience and the beauty of landing on Mars. Pretend that you are in the position of the camera. You've awakened in darkness after a rather bumpy landing. You slowly come to consciousness, and you remember you are no longer on the Earth. Your name is Imp. You've been hibernating in space for 7 months. The ride wasn't comfortable. Your forehead was pushed up against the solar panels. The rover was crammed against your left ear. The high-gain antenna mashed against your right ear. And that parachute canister straight down the spine. The scientists and engineers, both United States and German, that built you did promise that you would land in one of the most exotic places in the solar system, the flood delta of an ancient valley named Ares, a canyon so huge that it was capable of carrying 1,000 times the flow of the Amazon River. Dry for billions of years, the delta is now an ideal place to look for the diversity of rocks that contain the history of early Mars, and perhaps you will see some evidence in the pictures I'll show in a second of the dry landscape of the ancient water channels left from the last flood. For your first look, you're sitting close-legged on your pedals, coming out of your 7 months meditation, and you start to raise your head, and if I can have the first or the second slide. This is what you see. First, examine your trusty Sojourner rover. Healthy, ready to perform her mission. She's crouched down still, the way she was during the cruise, but will soon be released to stand at full height. Is this surrounding terrain safe for the rover? I'll let you form your own opinion. Are there clues here concerning the history of ancient Mars? Let's look together for the first time at the Martian landscape. Now, turn your head to the right and see the next slide, and we'll look to the other side of the pedal. Look in the distance. Those hills are not far away. It's too early for me to tell you how far, but they are fairly close. And look at that airbag bunched up on the right side of the rover pedal. And now I'm going to take you through a few close-ups within this landscape. And if I can have the next slide, we're looking towards the southwest, and the sun is over our left shoulder. You can see by the shadows. The sun's about 9:30 in the sky. And those boulders are the rocks that we will be investigating over the next few weeks. Those are the rocks that may hold the clues to the history of Mars. And in the next picture, we'll look at the rover and what it has to deal with. Now, as you notice, there are some dislocations in the wheels and so forth. This is due to parallax. As the camera turns its head, nearby objects move at a different rate than distant objects, and we have chosen to put the distant objects together, and we have let the dislocations be present in the rover. This is very hard to correct for, and we'll have to wait some time before we can get everything pieced together properly. If you remember, our camera takes frame-by-frame pictures like tiles. Let's look at another picture. There's the rocks and those distant hills. One hill has a little chunk out of it. I think that's on the border between two frames and will be corrected. We have only had 1/2 an hour to put these pictures together, and there are about 120 pictures here. This is a remarkable feat, and the image processing lab here at JPL deserves full credit. They have never done a picture of this magnitude in such a quick time period. Okay, let's look at another picture. Now, ignore that little notch in the hill. That's an artifact, but maybe it's a mirage. But this is a fantastic landscape. You see sand there. You see a diversity of rocks. This is exciting for us, and this is what we'll be exploring. Now, let's look a little closer. Next picture. This is the APXS. You see that little can. Let me see if I can point it out. There. This is the APXS. This is the ramp that's still stowed and can be deployed. Well, I'm not sure that it will be. And the airbag that is certainly interfering with the deployment of the ramp. Now let's look close by at the soil. Next picture. Oh, I'm sorry, we have one extra in the distance. There's a very large rock in the mid-distance. Remember, this is a view seen from sitting on the surface. Tomorrow, or at the end of Sol 1, we will extend our mast, and we'll have the view of from the perspective of an adult standing on the lander. And I think this is the final picture next, a close-up view of the rock. And if you look carefully up, you can see some of the soil has been disturbed here, obviously from when the airbags are being retracted. And you can see a close-up view of a rock. And I refuse to speculate at this point what that rock is, but we are going to be studying that and hope to tell you soon what our scientific assessment is. So, with those images, we are started on our mission. We're returning pictures as fast a rate as we can. Believe me, we want to see them as much as everyone else. And over the next few days, you will start to see some really more mature products coming out of this camera instead of this first quick look. You might ask if there were living organisms once here. You might ask many questions about these pictures, and these are questions we too will be asking. But remember, the imagination is very important to understanding this mission, and we will try and help stimulate your imaginations as we will stimulate our own and give you the sense of actually being on Mars. Today was a glorious day. The next few sols set the tone for the entire mission, and I will, with that, pass on to Mr. Dan Golden, our NASA administrator.
These pictures are breathtaking. It's a day I've waited for a number of years. And there are all sorts of rational science that'll come out of it. And I'd like to just speak for a few moments about the emotion and the passion, because that really does exist. I had the opportunity to go over and speak to the science team and the operations team. And these folks are feeling really good about themselves, and by God, they should. They have done just a wonderful job. And while I was in the operations room, I got a little blotchy. I had to stop speaking because of the emotion I felt in the room. Yesterday, when I opened the press conference, I said I declared this mission a success before it actually lands, because I wanted the people who worked on this program to understand that the NASA administrators trust them, and I had to put my money where my mouth is to say, I support people when they take risk, and if they have a problem, I'll stand behind them because I don't want to go back to the old ways of doing things. I want them to move in the future and have confidence that they'll be supported not by setting mediocre goals. However, I must say, this way is a lot better. And I just have wonderful feelings about the future, not just for the space program, but our country, given the incredible ingenuity and thoughtfulness and hard work and passion of these wonderful people. The 21st century is going to bring great things for our children. This is the second in a series of our new approach to spacecraft design. Watch out, world. Here comes NASA. Children of America, you're going to have a great future. Thank you very much. I'd like to turn it over to Dr. Huntress, who's the Associate Administrator for Space Science at NASA. He runs our space science enterprise, and it is through his leadership and dedication and teamwork and people selection, and he's a bulldog. He also doesn't give up. He got these programs started. So, Dr. Huntress, what's yours?
Thank you, sir. Boy, what a rush. Days like today is what the space program is all about, and I hope you all have really enjoyed the experience. The interest and excitement that's been demonstrated by everyone who's come here to this event demonstrates that this nation is still grounded in what makes it great, and that is a nation of pioneers and explorers, and you've had a chance to see them here. What better present can this agency give the nation on its birthday than this landing on Mars? It's just terrific. And Pathfinder was named Pathfinder because it was to demonstrate how to land on Mars at low cost. But something else was demonstrated here today that I want you all to really realize, and that is that Pathfinder is not the hardware. It's the people. And what a terrific team they are. They're a mixture of young, enthusiastic, excited, innovative, highly charged people with a few old scarred veterans to help them out. They were given a very challenging task, an exciting one, certainly, and told we didn't tell them how to do it, but to find their own way and not to fear. And they were individually given responsibility, they were given the resources and the authority to do what they had to do, and boy, did they ever perform. You've had a chance to see that for yourself here today. And the competence and dedication and confidence that these young folks have demonstrated, that's the way of doing things in the future here at the laboratory and around this agency. But you've not seen the big hero in all of this, the project manager for Pathfinder, because he's let these young folks who did all of this take the spotlight. And he showed them his trust, and they came through for him. And his name is Tony Spear. He's not here, but I want you all to know that he's a real American hero. In 1993, I told Tony, here's your challenge. I'm going to give you the money, and I'm going to get out of the way. And he put his team together, he gave them the responsibility, and he got out of the way. He's the captain of the ship. His name is Tony Spear. Thank you, Tony. Thank you, Pioneer, the Pathfinder team. Thank you very much.
John Zarella and Donna Shirley are watching this on television from a nearby location. Donna Shirley, what's going through your mind as you listen to what you're hearing right now?
Well, it's just, I agree with everything that Dan and Wes said. It's just absolutely magnificent. The pictures are just beyond our wildest dreams. The landscape is beautiful. It's perfect. It's absolutely perfect. The only thing we have to worry about now is what Brian is probably going to talk about, which is the condition of the airbags and the pedal and what they plan to do about that in order to get the rover off.
Maybe we should drop back in there and listen to what Brian has to say about that.
Right. I think that would be good. It'd be a good idea.
I'd like to do a couple of things first. As I said earlier, we landed in 1 pixel in that little ellipse, and we still don't know which one, but as you can see, it's a very happy one indeed. We are obviously not within any of those secondary craters that we showed you because we have a vast horizon with large mountains and plateaus in the distance. A spectacular place indeed. I'd like to show you, just for comparison, perhaps to look back 20 years to the first time that we land on Mars and show you what a different planet we have now found and what a different surface. The first one, please. Peter, can I have the... This is Viking 1, and for those of you who were at the press conference the first day we were here, you heard me excitedly talk about if we were to land in a place that looked like this, what great and wondrous things that I thought we could do. We could go over to this outcrop and we could look at these rocks at the edge and look at how boring this spot looks compared to where we landed. Next slide, please. This is Viking 1 in a different direction with the large rock called Big Joe and these aeolian or water-strewn dune fields here. Again, a very different looking place with a remarkably flat horizon at Viking 1, and perhaps even more so at Viking 2, the next one. This was dreadfully, sorry Jerry, dreadfully flat. And we were never, in fact, able to determine exactly where we came to rest with Viking 2 because there's just about nothing on the horizon here. And you've already seen the spectacular ranges in the distance, and we hope to start looking to those to triangulate to figure out where we are, and we've not done that yet. Second, you probably also heard me get extremely excited about all the things we were going to do with those rocks. And I think you saw how many rocks, how many rocks there are in that field. And already the science team is salivating to get their hooks into them. So there are many wondrous things to see in there and wondrous things to go and do, and we hope to start doing them very, very soon. You saw the imager worked flawlessly. The meteorology station is functioning perfectly, although the mast has not yet been deployed. We do not have health data on the APXS yet, but there's no reason to suggest it's anything but fine. All the science instruments are functioning perfectly, and we're very excited to get going. And to give you an idea of what we're going to do next, Brian Muirhead.
Thank you. Well, I think for everyone here at JPL, and I suspect maybe everyone around the world, today's results far exceed our expectations. The flight team is absolutely ecstatic. The morning's activities, the success of the EDL, that was just incredible, and I think Rob and Richard told you that story very well. And of course, our first downlink gave us that first EDL information, but at 4:28, when the high gain came online, was unbelievable for us. Because we, again, know how complicated this machine is, how complicated, what had to work right to get that high gain link there. And there it was, right on schedule. High gain was pointed within 1 degree of the Earth. It was perfect. We don't even test it that well when we do it. I mean, when we do our simulations, and we've done our simulations, they don't begin to compare to the perfection of the way the hardware, the software, and the operations team have worked so far on this activity. It's really, really wonderful. And we're just totally in love with our baby. I do have some stuff I want to show you. I'd like to bring up the first image. Let's see here. There we go. The thing that we're doing right now is and Jake will talk about this in much more detail, is we're assessing the ability to deploy the ramps and deploy the rover. And you can see in this image an airbag in the front side. This is the forward side of the rover. Let me have the next image up, please. Keep going. Keep going. I'm looking for the rear deploy. There we go. Let's try with that one, please. Okay, this image shows the airbag on the rear side. You can see how it's billowed up. That airbag is not fully retracted. We don't quite know why that is, but what we're planning to do, what the flight team is doing right now, is testing a sequence, and may have already even uplinked the sequence that will cause us to, and let me show you with this little model here. Okay, here's the pedal where the rover is on, and what we're going to do is we're going to lift that pedal up about 45 degrees, and then we're going to turn on the actuator that pulls the airbag, that's retracted the airbags, and we're going to turn that on for about 10 minutes and try to pull that airbag in a little bit more and get it down below the pedal. And then we're going to lay that pedal right back down. And we'll get back right to the position we're in. What we're doing right now is testing the sequence that does all that. We test it in the sandbox, and before we uplink it, then we'll uplink it, and then we'll execute that process. Then we'll use our camera again to take the same images, that the first images you saw, that assess the area around the rover, look to see whether that helped us a lot, which we expect it would, and then we'll make the decision about whether to deploy the ramps. I don't know right now when we would see those next images of this area. It's probably no earlier than 7:30, 8 o'clock. Unfortunately, I'm not in communication with the team right now, but that's what we're working on right now. We'll get those airbags retracted. The team will assess the ramp deployment, and then we'll get on with the rest of the mission. But for me, and I know for the rest of the team, this is, you know, we've scored a major home run here with this activity so far today. And on that, I'll turn it over to our illustrious rover manager.
Yes, thank you, Brad. Yeah, let me just point out a couple of the issues that have arisen as a consequence of our performing the assessment of this scene from the standpoint of the deployment of the ramps. I'll do that, but first I wanted to extend my own welcome to a friend I haven't seen for well over 9 months now, and that's the Mars Pathfinder rover, Sojourner Truth. Yeah. It looks just wonderful, and in fact, that solar panel is the first, actually that's the first time I've seen that solar panel. It's been covered every day, and it's been here at JPL and down at the Cape, so it was really very fortunate to actually see this here. But in particular, let me just point to a couple of issues here on the rear ramp deployment. Our concern is this little bit of airbag material that's currently sitting over the edge of the rolled up ramp. Although the picture breaks a little bit there, you can tell that that when the ramp is actually deployed, since the way it deploys, those two strings are broken. The ramp deploys out like a springboard and then falls down. The concern here is that if we tried deploying the rear ramp in this configuration, the edge of that ramp would catch on that airbag material and possibly fall back onto the rover or onto the pedal. So part of the strategy for retracting airbag material, at least from the standpoint of the rear, is to be able to remove a little bit of this material here and allow us to be able to deploy the rear ramp. On the front side, and maybe one of the prior images will show that a little better, if we can go back one or two. Well, maybe I can just describe it here. There's a fair promontory of airbag material out in front of the pedal that anywhere from 7 to maybe 15 centimeters tall above the height of the pedal itself. And again, that poses a kind of similar risk for the ramp deployment. If we tried releasing that ramp, again, the springboard would hit the airbag material first and conceivably could come back, although it depends a little bit on what that airbag is actually sitting on. One thought is that perhaps, there we are, that perhaps this airbag material is actually sitting on top of a rock. As you can see, we're attempting to make some estimates based on the rest of this terrain here. It looks like some fairly good-sized rocks in that area that in fact, that might be one of the reasons why this airbag is sitting where it is. But otherwise, again, the thought of being able to deploy or remove more of this airbag material, at least reveal what we're sitting on, and conceivably give us a little better clearance for releasing the front ramp. Also, as part of this assessment, we made a preliminary assessment as to where the ramps themselves would fall once they have been released. And in the front, they release somewhere in this area here on the other side of the airbag material. And on the rear, if we go back a couple of frames, I can kind of point out where that is. Okay, maybe there's one more. Yeah, that's fine. We could deploy in this area here with the ramp. Part of what I'm pointing to here is area that we actually have stereo image coverage in this image sequence set. And so as a consequence of that, we are actually taking measurements.
Donna Shirley, as you listen to this with us, give me your thoughts. How serious does this problem appear based on the pictures and based on what you've just heard?
Well, the problem appears that it's something we have to deal with. The rover ramps, we could try to deploy the rover ramps, but the rover team and the pedal team, the mechanical team, and the airbag team have looked at it very, very carefully, and they've concluded that the safe thing to do is to attempt this additional retraction. Now, if the airbags do retract more, and if it turns out that there are rocks under the airbags, it's possible that the ramps could be fairly steep for the rover to go down. So the rover team is currently testing a 9-pound rover here on Earth, which is the same weight as Sojourner is on Mars, to see how steep a ramp it can actually go down. And they feel pretty confident that the rover will be able to go down one way or another any steepness of ramp. So it's a delay, but we never figured that without incredible luck that we would get the rover off on the first day. We were going to try, but if it's the second day or even the third day, it's not a big problem.
Okay, Donna, stay with us. We're going to take a quick local cable break. We'll come back with more of the news conference, more of your expert commentary on it. Stay with CNN.
In what has been described as an extraordinary day, NASA engineers received the first images from Mars in 21 years. The images are one of many of the day's successes. Joining us now from the Jet Propulsion Laboratory in Southern California is CNN's John Zarella. Hello, John.
Hello, Relitza. And those color images that they just released a little while ago, certainly spectacular images of the red planet. In the distance, you can see what could be hills, perhaps mountains, and many, many rocks for the geologists to get a look at when they finally get Sojourner off of the vehicle, which may not come today, probably won't come today now. And joining me to discuss that is Donna Shirley. And Donna's been with us all day. And, of course, everything had gone so perfectly well. There had to be a problem of some sort, and what is it? You've got airbags stuck, and on what pedal? The one the rover's on.
Right, absolutely. Of course, the great galactic ghoul had to get us one way or another. Well, if we can look at the model here, Sojourner is on this west-facing pedal. This is west on Mars. The sun in these pictures is coming this way because it's morning, and these airbags are wrinkled up like this around the pedal, such that the ramps, as they have to unroll to let the rover off, could possibly have a problem. So what they're doing right as we speak is they're tilting the airbags up to 45, tilting the pedal up to 45 degrees. They'll pull the airbags in some more, and then they'll put the pedal back down, and then they'll take some more pictures to see if the ramps can now be unrolled safely.
And of course, what just happened with our little rover won't happen because it is firmly locked on that pedal.
Absolutely. It is still squatted down on the pedal, flat down to the pedal, and it is locked down so well that it was able to take all of that pounding during the landing without coming loose, and it's still locked down.
So chances are then tonight we will not see Sojourner off of the pedal.
Off the pedal. The odds are not looking good.
But we have many days ahead, and perhaps tomorrow will be the day. And things have gone so very, very well that obviously this is a hitch, but it is not a terrible, terrible setback. And if these engineers could get this vehicle to the red planet, there's no doubt they can figure a very good solution to get Sojourner off of the pedal. Relitza?
Certainly. Thank you very much, John Zarella, in front of Mission Control in Pasadena, California.
Thanks for joining us. The U.S. Space Agency, NASA, is about to hold a press conference on the Mars Pathfinder mission. We'll join that as soon as it begins, but right now we have this report from CNN's Dan Ronan about the journey to the red planet.
These spectacular color pictures are the second batch of images transmitted from the Mars Pathfinder. They show in brilliant detail the Martian soil and hundreds of rocks and hills. They're some of the first pictures taken from Mars in 21 years. Throughout the day, the color and black and white photos were transmitted in rapid succession, showing what appears to be the rugged terrain of the cold Martian surface. The pictures were made just hours after the Mars Pathfinder landed and began operating on the red planet. On board, the microwave oven-sized 6-wheeled rover Sojourner. Its deployment could be delayed until Saturday. Officials sent a series of commands to pull the Pathfinder's airbags under the probe so it does not snag Sojourner when it rolls out onto the rocks.
It's a delay, but we never figured that without incredible luck that we would get the rover off on the first day. We were going to try, but if it's the second day or even the third day, it's not a big problem.
It's expected the Sojourner will slowly creep across the Martian surface, taking pictures and sending back information to Earth. So far, the mission is nearly textbook perfect.
I think today the Pathfinder did what no one has done before, and of course they have a number of days ahead now of doing things that nobody has done before because nobody could do them before.
The Pathfinder left Earth some 7 months ago on the 309 million mile mission.
The little engine that could did, and we are just absolutely boggled by the fact that this fairly complex design that we've been thinking about and stewing over and testing and trying to make work really did the job.
21 years ago, NASA sent 2 Viking probes to Mars, and they landed in a generally flat area. Officials say this mission of the Pathfinder will provide much more information because technology is much more advanced. And Pathfinder was deliberately placed in an area that's much more rocky and dangerous. Officials say the landing was nearly flawless, coming down almost in the center of a bullseye within 30 miles of the computer projections.
This is really a spectacular day. It's gone better than we really possibly could imagine. Sometimes we're pinching ourselves saying, is this really real?
NASA wants this mission to begin gathering data about what type of technology will be needed to design future probes and a possible manned mission by 2012. Dan Ronan, CNN reporting.
Well, Mars has fascinated people for centuries, and Pathfinder's mission is likely to enhance that intrigue. CNN's John Holloman looks at the planet's enduring appeal.
The first historical references to Mars come from Mesopotamian astronomers in what is now Iraq. They found it in the sky 3,500 years ago. What set it apart from the other heavenly objects then still sets it apart: the color. Even without telescopes, Mars is the red planet. The Romans named it for the god of war. The Babylonians called it Nergal, the god of death and pestilence. When Nergal is dim, it is lucky. When bright, unlucky. Those words were recorded on a cuneiform tablet more than 3,000 years ago. Earthlings have always wanted to visit Mars. It's the closest planet to our own, and as knowledge of the red planet has increased, so has the realization that Mars and Earth are not that different. A day on Mars is just 37 minutes, 22 seconds longer than a day on Earth. Mars is tilted on its axis, just the way Earth is, which means there are 4 distinct seasons there, but because it takes twice as long to go around the sun, the seasons are twice as long. Its size, just about half that of Earth. Before the first telescopes, it was assumed that Mars was inhabited, and early telescope views confirmed that notion when it was noticed the planet was crisscrossed by what appeared to be canals. They must have been built by Martians. Percival Lowell used a 24-inch refracting telescope to look at the red planet. In 1895, he wrote, "The canals were the work of intelligent beings." He described Mars as older than Earth, with dried-up oceans, continents all smoothed down. He was convinced the canals were an elaborate irrigation system, and everybody believed him. Even after better telescopes showed the planet's barren surface and probes from Earth traveled the surface without finding any sign of life, the allure of Mars continues to draw us to its surface. The recent discovery in Antarctica of fossils which might have come from Mars and which seem to contain microscopic live creatures raises the intriguing question: was Percival Lowell right? And makes the race to the Martian surface even more exciting. John Holloman, CNN Atlanta.
The following is CNN's coverage of a live event.
More world news is ahead, but right now we join a news conference being held by the U.S. space agency NASA on the Mars Pathfinder mission. We're taking you live now to Pasadena, California, and the Jet Propulsion Laboratory for that. Let's listen in.
The path that the ramp would go through. So that's why we decided to try to get those airbags pulled a little more under the pedal. So can I have the next picture, please? Okay, you can see, here's an after picture, that it's considerably improved. It looks like, you can see the edge of the pedal here, and you can see that it looks like the airbags are comfortably below that edge. So the rover people took a look at that. The only problem is that we can't quite see the full extent of, we kind of had the picture chopped off here. So we're still not fully comfortable until we get a few more pictures back down to deploy that ramp. But it looks a lot better than it did before. Some of the other activities that we went through are to deploy our atmospheric structures instrument and meteorology science mast. So we sent the commands to do that, and Dr. Tim Schofield will tell you a little more about that later on. Let's see here. We also made the decision, based on images, to deploy the front ramp because it looked like there were no instructions in front of that. The sequence that we sent up actually does a couple of things. It deploys the front ramp. It'll also release, fire the pyros to release the rover, and then the rover will actually stand up. However, due to the activities that we had to do before then, this was pushed very late in the Martian day, and we did not get confirmation, which we were kind of expecting because we sent the sequence so late. We did not get confirmation of those activities because the Earth had already set. So tomorrow morning we'll get our first confirmation that those activities were successful. We are working a couple of issues. The things that we had planned to do, or hoped to do rather, today that we did not get done was, first off, we wanted to get the IMP deployed. Now that means the IMP is on an astromast, and what we wanted to do was fire the pyro to release that mast and pop it up to its full extended height. The reason that we did not deploy it today was due to the airbag retraction activity and some of the other activities. We did not get a chance to take our what we call our insurance images, which basically is a set of images taken by the camera from its stowed height, so that if something were to go wrong during the deployment process, we would at least have a full pan of the surrounding area. So we wanted to make sure that we take those insurance images before we deploy the camera. So our plan now is to do that tomorrow, sometime tomorrow afternoon. The other activity, of course, is we did not get a chance to drive off the rover. The major issue that we are still working right now is we have an issue with rover to lander communications. The first health check, or the first couple health checks, we did get good data from the rover, but we have not been able to get communications from the rover since then, and Jake will hopefully be able to add a little more to that. That's it for the lander.
Okay. I wanted to review a little bit some of the things we've learned about this remarkable place that we have just discovered, give you some idea of what the thinking of the scientists on the team is, and some idea of the overall excitement among our science team, almost 100 strong, about this place that we've just landed at. Shown in this first image, this was released at the last press conference, we see a terrain that obviously has a series of dark rocks in it with light sort of reddish dust that you can see here. In some situations like this over here, it almost looks like these rocks are imbricated one on top of another as if they were deposited in a high flood regime. And that's the early thinking that some of these rocks may be flood deposited, which of course is not at all surprising since this is the biggest flood in the solar system. Next one. That's a closer up look, and you can see these rocks look like they're sort of tilted on end with structure within the rocks as well. So some very interesting things to look at. Again, a reddish dust. There's different colors rocks. They're dark, but there is some indication in some of these areas that there may be some slightly different color rocks, as shown by red-blue ratios in these images. Next one. Again, off to the horizon, this site has substantially more relief than anywhere we have ever seen on Mars. We believe these are, hundreds of meters that we're looking at here. And as I showed you earlier today, both of the Viking sites that we've been on have been remarkably, remarkably flat. And so we actually believe we have an idea of where we've come to rest on the surface of Mars by looking at these hills in the distance and using the directions that those hills are, and I'll give you some idea of that. Next one. Finally, we do see a variety of different, not just rocks, as I said before, but finds as well. It looks like there's a variety of different finds in this site. There's this so-called cloddy material, which is kind of hard to make out in this, but it looks like it's a little bit more indurated than some of the real dusty drift material here, and there's some indications of almost sort of a white dusty drift material. So we have a much wider variety of materials at the landing site than we've seen at either of the other two Viking sites. And again, that bodes very well for our continued investigation of this site. Next one. So where do we think we wound up? Well, I would argue from what you're seeing on the horizon, we see large hills on the horizon. There's substantial relief at this site that we are not, and I repeat, we are not within any of these secondary craters. If we were inside a crater, we would see a nice bowl around us and we just wouldn't see anything out in the horizon. Certainly not things that look like they're that far away. So we have actually think that we are up out of this ellipse, which is the nav team's ellipse, somewhere off in this region here to the northwest of this crater, which we believe we have identified in the images. And this is a preliminary one. I won't go into detail, but perhaps tomorrow morning we'll have a more detailed description of why we think we are out on this plain out over here. I think that's it for the images. Just one other item. We have finally gotten an opacity measurement. That is how much material or dust lies in the sky. And as you all recall, there was some disagreement among the Hubble observationalists that were saying that we might see a deep blue sky and a very bright white clouds. It's clear we do not see that at all. In fact, what we see is an opacity of about 0.5, which is rather dusty. And probably, I guess Mars has the last word, as it always does. I was wrong on my prediction that it would be clearer than the Azusa Fire Day here in Los Angeles. It's about the same as that, okay? So we do have a dusty sky. It looks very much like Viking did. It's a salmon-colored sky, and that opacity is a bit higher than what we had expected, and that will reduce our solar power just a tad. And with that, I'd like to turn over to Jake Matijevic to talk about the rover.
If we can go back briefly to, I guess, the prior image might be helpful, showing the, back one to the, showing the, one of the early images of the rover and the, on the pedal. Yeah, that one. As Guy pointed out to you that in the confirming image that we took a little later, this section of airbag material has been brought down behind the rover's pedal and now clears up an area in front of the this pedal and gives us now another attempt at calculating the actual position where the front rover ramp would deploy. That ramp will deploy in this area at about an angle of 24 degrees, maybe a little shallower than that. So this is actually a very safe, would be a very safe deployment for the rover off the front of the rover's pedal. I think what Guy mentioned, there was still some obscuration in the rear. We also took some additional rear images after this pedal motion and airbag retraction took place, and we had some obscuration in that area of precisely the area where we were looking to get some confirmation, where the airbag material was laying over one of the rear ramps, a portion of the rear ramp. At least from the images that we did see, it looks as though that material has also been retracted, but we didn't get a full view of the ramp as yet. So we went ahead with the commands to actually deploy the front ramp, and as mentioned at the beginning here, that command went up. The confirming images have been were queued to be taken, but the data will not be returned until tomorrow morning during our first downlink. The second issue that Guy raised had to do with the problems we've had with communications between the rover and the lander. The way that's manifested itself has been in the form of a high percentage of garbled frames and transfer between the two modems. For those of you who are not familiar with the communication system, it's actually a radio modem system, one on the rover, one on the lander. The rover, as link commander, routinely and regularly interrogates the lander for commands, and the lander's modem is on from the early morning period till late at night, and actually acting in sequence with the rover, attempts to communicate, attempts to receive these packets of information that the rover is sending, and stores them and buffers them for transmission to Earth. The manifestation of the problem we've seen has been of the form where the rover has continued to try to send telemetry to the lander. Some of it gets through. There are more along the lines of communication sessions that set time, begin the acknowledgments associated with commands and telemetry sessions, but quickly abort about the time when the larger frames of data containing information about the rover's health, other status information as we go through the command sequences on the rover, the confirmation of the execution of those command sequences being reported by the rover to the lander. We've tried one attempt to power cycle the lander's modem. That didn't seem to clear the problem at this last communication session. We're going to try several recycles or power recycles during the night. And of course, because the rover is power limited, it routinely and regularly power cycles its modem. So we're going to see if that sequence of activities over the course of the next several hours doesn't clear the problem by tomorrow morning. As Guy also said, we did queue the sequences that would stand the rover up. In all likelihood, the rover did not receive those sequences. This communication problem is severe enough so that sequence probably was not received by the rover. But again, we will not get confirmation of that until tomorrow morning's telemetry session. There's no danger at this point either for the rover. The release pyro events that we just did command that include releasing the forward ramp, releasing the rover, and releasing the tie down of the APXS sensor head can proceed without these other portions of the command sequences on the rover being executed. The rover is tied down even after these tie down cables are released. The rover actually has 6 wheels caged prior to stand up, so it's not going anywhere at any time over the next several hours. And we have full opportunity tomorrow to, once we've gotten the confirming data, to repeat this process of attempting to stand the rover up. But in all likelihood, what's happened today is when we get these confirming images, we'll see a front rover, a front ramp deployed, still a stowed rover on the lander's pedal, and an opportunity to try to drive the rover off the pedal tomorrow. So with that, I'll turn this over to Tim Schofield to talk about the ASI map situation.
Whilst all these great images were coming down this afternoon, we were having our own excitement on the ASI Met, verging on nervous breakdown. We planned to deploy the mast after the first high-gain downlink, after we'd expected the pictures that were displayed. We found to our dismay that we couldn't see the mast in the pictures that came down due to a slight difference between the testbed hardware and the actual flight hardware. An object near the camera was obscuring the view of the mast, so we had no means of telling whether the airbags were blocking the mast deployment or not. We have very delicate thin wire sensors on these masts, and even brushing against the airbags would tear these sensors. We delayed any action until the second downlink, where after the rover petal manipulations, and there the pictures are just a little better and allowed us to see the bottom corner of the mast, and that looked clear, and other indirect information persuaded us that the petal, the mast itself was clear of the airbag, which probably wasn't overlapping the petal. And this indication was also strongly reinforced by the mission manager, who reminded us that he was losing 20 or 30% of his solar power from the panel whilst the Met mast was down. So we decided to deploy the Met mast on what information we had, and in the final downlink, the last packet received in the final downlink showed the Met mast had deployed. Some images showed the mast vertical, and we had one data session in the fully deployed position. All of our sensors are working correctly. And the first figure shows the Viking temperatures with a few of our sessions average superimposed on that data. Only the last point, this point here, is with the Met mast deployed. Before this time, all the temperatures are very much higher than Viking, almost at freezing point here, 32 Fahrenheit. When the mast deploys, we're looking higher in the atmosphere, a meter above the surface rather than a few inches. The temperature drops down much closer to the Viking level. Should remind you that Viking was making measurements at 1.6 meters, so we would expect to be a little warmer than Viking during the day, because we're still close to the surface. So this, for example, this is 1.6 meters, this is 1 meter, and this is a few inches above the surface, and it sort of gives you an indication of how the temperature is varying with distance from the surface. As we'll get no more data today, tomorrow afternoon we should expect to see an entire daily cycle in our data set and get a good comparison of the daily cycle on Mars. The next image shows same data for pressure. Pressure is not influenced by the mast deployment. That's taking measurements out in a completely different location on the spacecraft. And we were astounded by the agreement between the measurements we'd taken and the old Viking data. We have much more resolution, but we seem to follow pretty much down this Viking curve for this time of the day. The last point is about 1:45 in the afternoon. We have preliminary wind measurements for this last point in the mid-afternoon. The wind is blowing from the east-southeast. It's very light, a few meters a second at the most at that particular time. Tomorrow we should be able to produce time variations overnight and during the most of tomorrow of the variation of wind. So after a bit of nail biting on ASIMET, we're all now feeling very pleased that we're seeing good quality data coming back. Thank you.
Just one more thing before questions. To give you some idea of what we're expecting tomorrow, we obviously will try to get the rover off by the imaging tasks we've already talked about. We also will almost certainly not deploy the IMP on its mast this evening and wait until tomorrow to take a series of panoramas additional to the ones you saw on NASA TV coming down this evening. We now have a panorama in that one color, but we would like to get panoramas in other colors as well prior to deploying. So we will maintain the imager in its state. We will continue to take weather data, and we will try to get the rover off.
Okay, we've all had a very full day, and many team members have to do yet more work, so we'll try to keep the Q&A session fairly brief. Let's start over here with Casey.
I'm sorry, I don't quite understand how you're going to be trying to communicate with the rover or recycle, do things this evening. Hasn't the Earth set? And could you give us a little time schedule for tomorrow when things might happen, Earth time, and what time, when that is on Mars?
Sure.
Thanks.
I'm sorry, I didn't mean to be obscure here. The rover is actually running the first sequence that it received this morning. That sequence contains commands that actually are executed overnight and tomorrow morning. During the course of the execution of those commands, it routinely and regularly attempts to communicate to the lander. Now, those commands are synced up with other commands on the lander, which bring the LMRE, the lander's modem, online for communication with the rover. So the sequence of activities is such that the rover is over the next several hours, will be continuing to attempt to communicate with the lander. Overnight, the rover will shut down and wake up hourly, continue to attempt to communicate with the lander, and this will go on through really through the rest of the morning as well. The command sequence that's on the rover right now actually runs into day 3. runs rather benignly in that regard, periodically just communicating health check information, health status information concerning the rover. The sequence of events that will take place tomorrow start roughly with the first downlink that is coordinated with about 8 or 9 o'clock. I believe it's actually 8 o'clock a.m. local time on Mars, which is roughly about 4 o'clock 4 o'clock in the afternoon Pacific Daylight Time. And then we proceed from there through what is something like what took place today. There'll be opportunities during the course of the remaining evening and into the into the night, where we'll have opportunities to be able to command sequences to the lander to be sent to the rover. We'll have perhaps some other activities to perform both on the lander and possibly also on the rover to try to clear this problem. And that's those sequences and those activities we'll be talking about building tonight and tomorrow morning.
Okay, Todd?
Todd Halverson of Florida Today for Jake. I'm wondering if you could give us an idea of when you think the earliest the rover could roll off. And for Mr. Schofield, I'm wondering if you could tell me again what the temperature was in Fahrenheit and what the wind speed was that you saw in your data.
Okay. I believe the earliest we'll be able to roll off tomorrow will be something on the order of about 7:30 tomorrow night. That's local, that's Pacific Daylight Time.
Okay. I'm sorry, there was a part
on the temperatures, after the mass deployed at about in the heat of the afternoon at about 1:45, we showed on our top mass sensor about 1 meter upper temperature of about 255 Kelvin, which corresponds roughly to about 0 Fahrenheit.
Okay, want to get the microphone to Bill Harwood?
Just got me. Bill Harwood, CBS. Is there any idea what the possible cause is for the garbling between the modems? Have you seen a signature like that on the ground in any testing? I mean, or is this a complete unknown at this point?
We haven't seen it for some time. There is some indication. We've been polling our engineers, and they've been kind of going back through their activities, their notes and such, that we've seen a variation of this, where the two modems clocks are out of sync for one reason or another. We think the power cycling is a means of clearing that. There may be other ways of attempting to clear the problem, which we think is on the lander side of the interface. But I wouldn't like to speculate here at this point. I don't think we've had a really adequate time to fully diagnose this problem and give you a most likely reason as to why it's occurred.
And a quick follow-up, and this may be a dumb question. I was under the impression from what you said that you see this with big chunks of data going through as opposed to smaller packets.
No,
is that right?
No, actually, we've seen small chunks of data going through. The large chunks of data are not getting through, and that's consistent with a communication rate that's degraded quite a bit.
And that's where I was going with that. Is there, if you never could resolve something like that, can you send commands in smaller chunks and get around that problem down the road at some point?
It's possible to do that. Again, I would prefer not to speculate at this point.
Jim Vocek, CNN. When the rover drives down tomorrow night, do you have a plan at this point where it's going to go exactly?
In all likelihood, it's going to go down the front ramp. This is what we'll attempt to do tomorrow is consistent with what we were trying to do on the best of circumstances tonight, which is to really do a very short traverse at the end of the ramp, do a turn, roughly anywhere from 45 to 90-degree turn right into an area that's clear at the end of the ramp, and put the APX down to take our first night or first soil measurement overnight on Sol 2. That would be the nominal plan to be performed tomorrow.
Okay.
Eric Simon, Mosaic.com. I have two questions. Number one, if the option always existed to deploy the ramp out of the rear, why was that option not pursued? And question number two, if the modem issues, the communication problems are not resolved, how will that impair the rover's mission?
The problem with the rear ramp deployment is that we didn't get a confirming image on this downlink that showed that the airbag material that was draped over the one edge of the ramp had been removed as a consequence of the airbag retraction and pedal move activity that was conducted tonight. That was the reason why we didn't deploy the rear ramp. Otherwise, the images that we did get of the rear area of the pedal indicates that the airbag material did move, that there does not appear to be any obstruction otherwise of the ramp deployment. We just did not want to risk deploying that rear ramp, but, given the absence of this confirming image information. Again, I'd like not to speculate as to what would happen if we do not reestablish communications. There are some contingency options that could be exercised in that instance, which will eventually drive the rover down the front ramp and onto the surface.
Leo?
Leo Enright, BBC. Can I really understand precisely this modem thing? If the modem isn't fixed, the rover's going nowhere. Is that basically it?
If the modems were not fixed, okay, the contingency options include the execution of commands that are already stored on the rover to do what I've just mentioned, deployment down the front ramp and deployment onto the surface of Mars. We would prefer to command that activity from the lander, and of course, any activities that would follow this would require communication between the rover and the lander to get to sites on the surface, et cetera, to do the kind of mission we're talking about. We have every confidence we'll find a way of being able to resolve and fix this problem so that the mission can proceed normally from this point on.
Can I just follow up and ask, what is the scale of the troubleshooting that's going on? Have the contractors been called in? Are we talking about teams who are working tonight, through the night?
We were trying to organize that when I left. I'm sorry, I don't have more information for you at this point.
Okay, let's just take a couple more questions and see if we can wrap up. Seth, the front row.
Seth Bornstein, Orlando Sentinel. Just to follow that a little bit more, I guess I'm tired and having trouble. So you're saying if the modem problem isn't cleared, you can still get down on the ramp, but then after that you really can't do anything. Is that, you can't, if Matt wants you to go to Rock X, you really can't go there, right?
That's correct. We won't be able to do a commanded mission if we don't fix the communication problem. But again, I'd like to think in terms of being able to resolve this problem, in the next day or so.
And Matt, once, let's say everything goes well, and you go down and do that, get up and do the little just right turn and take a look at the soil. After that, you see this whole field of rocks from this panoramic view. Besides that first one where you just look at whatever's nearby, is there already a priority, which rock, which whatever you want, and what is it?
Yeah, there's, in fact, the Mineralogy and Geochemistry Science Operations Group, that's what our working science groups are called, SOGs, has already prioritized rocks off the front and rear ramp. There is a sort of...
It's a reddish rock.
No, it's a deep blue, a deep dark rock that would be in the direction that he turns. And the whole point of going down and turning right is, in fact, to get to that one. I could probably show you which one that is if we try to cycle through the images, if you're really interested.
That what makes it so interesting.
Oh, it's a dark rock that doesn't have, there it is.
Go to the previous one.
Yeah, go back one, please. That's it, right?
That's it there, yeah.
This is a rock that does not look like it's covered with dust. It looks like it's a deep blue native color, or deep gray, if you will, and thus implying that you're looking at the rock mineralogy and not dust there. So that would be the target for Sol 3, provided we go off the front ramp. If we go off the rear ramp, we also have a rock that meets the same sort of criteria. It's dark and deep in color, and it does not appear to be dust covered.
The size and distance of that rock, I guess?
Well, we don't have the stereo out there yet, but it certainly looks within range. It's certainly smaller than a meter.
Okay, we have two questions from Kennedy Space Center. We'll take them now.
This is Phil Chen of Earth News.
I guess starting from when the crew stage separated through your command to fire the pyro to let out the ramp, how many different pyrotechnic devices were set off either over or on the surface of Mars? How many fireworks did you have on Mars today?
Well, the number was in excess of 40.
Yeah, I think
I don't have an exact number.
42 just to get down to the surface, and then there's additional ones to unlatch the imp and the high gain and so on. So we're probably of the order of 50 or so.
Okay, and a much bigger number. Do you have any estimate on the number of internet hits you've had to your web page and all of your mirror pages around the world today?
Yes, very close to 100 million.
Okay, do we have another question from Kennedy? That's it. Okay, I guess we'll call it an evening. Thanks for joining us. Our first press event tomorrow is a 10 a.m. briefing in the auditorium.
Okay, well, you were watching a live press conference held there by NASA scientists discussing the Mars Pathfinder mission. They were trying to be very positive and upbeat, but apart from a partially deflated airbag blocking the Sojourner's path from the spacecraft, there is also a communications problem sending commands to the rover, which might hamper the whole mission. NASA are playing down that worst-case scenario, saying a lot can be done on Saturday daytime, U.S. time. They may well deploy the rover from the rear, but unless the communications problem is resolved, they won't be able to communicate with the rover. But as I say, they are trying their best to sound very positive, saying that everything is going according to schedule. They were showing off some rather fancy photographs from the surface of Mars, imparting a lot of the scientific knowledge which they've already gained at this stage. They also said a staggering figure that somewhere in the region of, was it a million or more internet site hits they've had just in one day since their mission began. That's the world news for now. We'll have a full report at the top of the hour, but World Sport is coming up next.
This has been a CNN Live event.